Hello everyone, welcome back to Mathematics. So for this video, we are focusing on this year's trial paper for Selangor paper 1. Alright, so the difficulty of this paper, if let's say compared to the papers that we have done this year, which is the Kedah and the Sabah one, I would say Selangor is slightly easier compared to the Sabah and Kedah paper 1. But of course, this paper has its own difficult questions as well, which I realized in this paper there are a lot of proving the formulas in the formula sheet questions. Right? I think there are around 3 to 4 questions. Right? So for these kind of proving the formula ones, I would say my advice is do not memorize the steps, but to understand the steps and how does it work to prove the formulas that we want to prove. Okay? And for this year, I tried to do something new, which is to add this unique label, which you can see on the top right here. So if you see these labels when we are discussing the questions, means that these questions are much more complex, and let us put more focus into those questions. Right? Because these questions, I would say, appear more often in the trial paper compared to our questions that we do in a textbook or the exercises books. Alright, so let's put more focus onto those questions. But just a heads up for y'all, for some of the snapshots of the questions in this paper, it might be cut off, so means there are some words or some sentences which are incomplete. Alright, I think it's because this year's trial paper, they didn't really scan it properly, so some of the questions, they are cut off. Right? So in this discussion video, I try my best to complete those cut off words or cut off sentences if they are very, very important to solve the question, right? But if you have any questions regarding the cut off words or the cut off sentences, feel free to put your questions in the comment section below, right? I try to address them as soon as possible. Alright, so without further ado, let's go through this Selangor paper 1 together. Alright, the first question in this paper coming from circular measure, and in this diagram we have a circle and it's split by 2 parts. Alright, so if you see these 2 parts, they are actually touching the center of the circle, which is O. So since it touches the center of the circle, these 2 parts are also called the sectors of the circle, right? Because it touches the center. So here we have a big sector and a small sector here, but do we have other names other than big sector and small sector? Yes, there is. So for the smaller sector, it is also called the minor sector. So minor means smaller, and for the big sector here, it's also called the major sector. So major means bigger. Alright? And also in this question, they gave us the angle of the minor sector, which is 1.2 radians, and they gave us the radius of the circle, which is 8 cm. So now in this question, it tells us to find out the area of the shaded region. Right? The shaded region is here, and it is actually the area of the major sector, right? So we need to figure out the area of the major sector, and for our answer, we need to write it in 4 significant figures. Okay, so this is significant. So what is significant figures? Later I'll explain what it is. Okay, but I put a star here just in case I forget. Alright, so to find out the area of the major sector or the shaded region here, we can look at the formulas from this chapter, from the formula sheet, which is formula 27 and 28. Right? So if we look at this formula, it is helping us to find out the area of the sector, and we can use this 1 over 2 times r square. R is the radius, and theta. Theta is the angle of the sector. Alright, so let's use this formula to find out the area of the shaded region. Okay, so let's start off with 1 over 2, and we multiply the radius of the circle or the sector, which is given here, right, which is 8. And don't forget the square here. Alright. And for the theta here is the angle of the major sector here, which is this one. Okay, so we do not have this yet, so let us find it. Okay, so if you combine the theta here and the angle of the minor sector, it is actually one circle, right? Or one cycle, or one turn. So we know that the angle for one turn is 360 degrees, or in radians it is 2 pi, right? So if we know the angle of the entire thing here, so we can use these angles and minus with 1.2 radian to get the theta. Alright, but for the theta, is it degrees or radians? So we need to look at the formula here. Alright, so these two thetas, is it degree or radians? Alright, so in the formula sheet for these two formulas, the theta will be using radians. Right? Only these two formula uses radians. The other formulas that uses angles, all of them are in degrees except these two formulas. Right? So please make sure that you know that these two thetas uses radians. Okay, so coming back here to find out the theta, we need to use the radian format, right? Which is 2 pi. So 2 pi minus 1.2 radians. Okay, so let's write out our working here. So angle of the major sector here would be 2 pi minus the angle of the minor sector, right? Which we know it's 1.2. So for the pi here, let us use the value given here, which is 3.142. And if we minus, we will get 5.084 for our theta. Okay, so let's use this value and multiply here. Right? And if we put this into the calculator, we will get 162.688. But is this our final answer? Well, we need to look at the condition of the question here. It says we must correct it into 4 significant figures. So these significant figures is actually another way of asking to convert our answer here into how many decimal places. Alright? And what is significant and figure mean? So significant is actually another word for important, and figures here is actually digits. So means from our value here, what are the top 4 most important digits? And from the 4 digits itself, we need to see how many decimal places does it have. Okay, so let me repeat. 4 significant figures of 4 important digits means in our value here, we need to see which are the top 4 important digits, and we need to see how many decimal places does it have. Alright, so now we'll be asking, how do you define important? So important here means the value of that digit is bigger. Alright, so if we compare 1 and 8 here, which is bigger? So if the 1 here, it represents 100, right? And the last digit here, it represents 0.008. So if you compare, of course, the value in front is bigger, means it is more important. Alright, so if you want to find out the top 4 important digits, we need to start from the front, right? So it will be 1, 2, 3, 4. So now we have identified the top 4 important digits. Now we will see how many decimal places does it have. So we have one value which is behind the decimal. So it means that it has 1 decimal place. Okay, so this means in the question here, we need to write our answer into 1 decimal place. Okay, so let us change this value into 1 decimal place. So we round up, it would be 162.7 cm square. But before we go to the next question, I just want to have a revision on something else. So some students will be confused with the word sectors and another word which is called segments. Alright, so what is the difference between sectors and segments? So segments are actually the part of the circle that does not touch the center of the circle, right? So for example, the center is here, but our line here, it doesn't touch the center of the circle, and this area will be called the segment. Alright, so I give you another example. Let's say the center of the circle is here, and the line that I've drawn, I didn't touch the center of the circle, but the area here, I include the center. So this is also called segment because the line here does not touch the center of the circle. Alright, so this is the main difference between sectors and segments. For the lines in sectors, it touches the center, but for segments, it does not touch. Next question, going into linear law, and here we have a straight line graph, and we need to express y in terms of x. So means that we need to form an equation where the left side of the equation must be y, whereas the rest of the things on the right side. So one of the things is x. Okay, so meaning we need to form an equation based on this graph here. But if you look closely to the axis here, it's not what we see all the time. So for the x-axis, it's small x, right? The small x here, which we see all the time. But if you look at the y-axis here, so now it's not y anymore, right? It's not y anymore, so now it's ln y. Okay, so from these axes, how are we going to form an equation here? Right, so this one no need to worry because this is a straight line, right? For all of the straight lines, they will always follow the similar format, which is y equals to mx plus c. But this time, we are using big Y and big X here instead of the regular y equals to mx plus c, which is this one, which is small y and small x. So now you may be asking, why this time we need to use big Y and big X instead of small y and small x? Alright, reason is because it won't be as straightforward as small y and small x now. Because if you see in this diagram, if you see y-axis, there are some other things inside of it. For example, the ln here. So we cannot just straightforward use small y. Okay, because small y and ln y, there's a difference, right? So let me give you an example here. So let's say big Y. Previously, it was just small y, right? So now it can have other things inside. So for example, y square, y cube, log base 10y, or maybe it can have x inside of it also, y over x. Right? So if you see, there are some certain other things inside of the y here. So to make it easier for everyone to understand, we are going to use big Y. Okay? Because it has some other things inside of it, and it's not just y only. Right? Not just the small y here. Alright, so coming back to our equation here, so we are going to form y equals to mx plus c according to this graph here. Alright, so we need to figure out what is y, m, x, and c here. So big Y here is the y-axis of this graph, so it's ln y. Alright, ln y. big X here is the x-axis of this graph, which is small x, and M is the gradient, and C is the y-intercept. So now we are missing of M and C. Okay, so let's figure out M and C here. So for the M, since we already have the coordinates of these 2 points, so why not we use the gradient formula to figure out the gradient, right? So let us use this point as the first point. So y1 minus y2 would be the y coordinate of the first point, which is 7, minus the y coordinate of the second point, which is 1, and we divide with the x1 and x2. So x1 is the x coordinate of the first point, and minus off with the x coordinate of the second point. So once we calculate, it would be 2, right? So the gradient here is 2. So how about C? Alright, so since we have the gradient already, and we have the coordinates of the points here, so why not we use one of it and we substitute inside here? Okay, because technically this 2 is actually x, right? The x coordinate, and 1 we can substitute into y because it's the y coordinate, right? So why not we use that way? We substitute the point and the gradient inside y equals to mx plus c to figure out the value of c, which is -3. Okay, -3. So now we have all the things in the equation already, so why not we substitute all the things here, y equals to mx plus c. Alright, so now going back to the question here, it says express y in terms of x. Y is the only thing on the left side, which means this ln, we need to move it to the right side. Okay, so let's understand what is ln first. So ln is actually log base e y, right? Log base e y. So how are we going to move this log to the other side? Okay, so this one we need to look back the things that we have learned in logarithms, right? And if you see my videos, usually I would share the 3-step method to solve any kind of logarithm question, right? So the first step is to change the base, right? The second step is to manipulate using these formulas here, but these 2 steps we don't need it because we only have 1 log and it's very simplified already. What we need is the third step, which is to change the form, right? So if you see the form that we have now, it's the logarithm format, right? There's a log here, and there's a base, which is e, y is y, and x here is 2x minus 3. So what we need to do now is to change it into the index format, right? The index format. So how do we do that? Very simple. It's just moving the base to the other side, right? So once you move it to the other side, it would be here already. Okay, the base of this value. So meaning for this e, I am going to push it to the right side. So here would be e, and the 2x minus 3 would be the power already. And as you can see, the log here disappears, right? So this would be our equation, y equals to e power of 2x minus 3. For question 3 focuses on progressions, and in part A, we are focusing on a geometric progression, right? So let us recall back what is geometric progression. So geometric progression is a sequence of numbers where if we want to find the next number, we can either multiply or divide a value, and usually the value is r. So a quick example of what is geometric progression would be, so let's say we start off with 2, and if we want to get the next number, let's say we multiply 2, right? So 2 times 2, 4. And if we repeat the same thing to get the next number, so 4 times 2 is 8, and we multiply 2 again, it will be 16, and so on. Okay, so this is a geometric progression, and if you want to find the next number, it is always multiplying with 2. And these values are actually the R. Alright, which is also called the common ratio. So coming back to the question here, it says we need to show. Okay, so this is actually show that the sum to infinity, right? Sum to infinity progression is using this formula with this condition, modulus R less than 1. Alright, so this question tells us to prove one of the formulas in the formula sheet, which is formula 13. Okay, so how do we prove this formula? Alright, before we do anything, let us understand what is this first. Alright, why is there modulus R less than 1? Okay, so this is actually a condition when we should use sum to infinity. Okay, because if it doesn't satisfy this condition, then we cannot use this formula. Right, so to help you understand this, let me give you 2 examples of R. Right, so one value of R would be satisfying this condition. So let's say the R here is 0.5. Alright, because 0.5 I put into the modulus here, it's still 0.5 and it's less than 1. Okay, so this satisfies the condition, but the other R, let me give you a value which does not satisfy the condition. Let's say it's 2, right? Because 2, if I put inside here, modulus 2 will still be 2, and 2 is not less than 1, right? So this one does not satisfy the condition, and here let us see what are the differences in the results, right, when we use the formula here. Okay, so for each example here, let us use the same value of A, but different values of R. So let's start off with R equals to 0.5. So the sequence would be, so 1, okay, because we start off with A equals to 1, so the first value will be 1. So 1, and then we multiply the R value, which is 0.5. So the next number would be 0.5. And we multiply the same value, 0.5, then we will get 0.25. And we multiply 0.5 again, and you will get 0.125, and so on. Okay, so if we use the formula, which is S infinity, it would be A is 1, right? And 1 over 1 minus the R value, which is 0.5. So the S infinity value would be 2, which makes sense, right? Because the sequence, if you see, it's getting smaller, smaller, and smaller, and smaller. So if you can imagine the values at the back, right, it's almost 0. So if we sum up all of the values here, it would be 2. Okay? But let's see when R is equals to 2. So let's form a sequence first. So let's start off with 1, which again, A is equals to 1, and we multiply the value of R, which is 2, so here will be 2. And we multiply 2 again would be 4. Multiply 2 again would be 8. Multiply 2 again would be 16. So if we find out the sum to infinity using this formula again, so A is 1, and over 1 minus the R value is 2. So if you see, why suddenly is negative 1? Which is weird, right? Because there's a negative here. If you see the sequence that we have just now, none of the values are negative. So how did this negative come out? Right? So that's the first thing. The second thing is the 1 here. If you see here, if we add up all of the values, it is actually more than 1, right? So this value 1 also doesn't make sense. So this entire thing doesn't make sense. Okay, so let's find the S in infinity by ourselves, okay? Without using the formula. So if you can imagine, we add 1 plus 2 plus 4 plus 8 plus 16, but if you imagine the values at the back, it can be very, very big, right? It can go to thousands, it can go to 100,000s, it can go to millions, and go to billions. So Since all of the values here are positive, means if we add up all of them together, it is actually positive infinity. Meaning, the s to infinity does not have a specific value, like the example given here. For example, here you can see that s infinity has a value which is 2. But for this kind of cases, the s infinity will go up to infinity. So meaning we don't have a value for that, which is why the s to infinity formula fails here, because it couldn't capture the infinity. Okay, which is why for certain values of r, we cannot find the s of infinity value, which is why we set this condition. It only works when modulus r is less than 1, right? Otherwise, it would be positive infinity, like this case here. Okay, so that's the reason why we need to add this condition here. And now let's go back to our question here. So again, we need to prove the s to infinity formula, but how do we do that? So actually, this sum to infinity formula is actually a special case of Sn, because this is when s is equals to infinity. So if you want to prove s to infinity, you first need to look at the formulas of Sn, which here there's a headache because it has two formulas. So which one to choose? Okay, so the easy way is you can look at the denominator. Here it's 1 minus r, right? So which one has 1 minus r? This one, right? So we can just use the second formula. Right, but if you want to understand the reason why, okay, there's a condition when should we use 1 or 2, right? So for formula 1, it is when modulus r greater than 1. Okay, so examples of modulus r greater than 1 would be 2, 3, or 4, or the r value can be negative, right? So negative 2, negative 3, negative 4, right? Because if we add the modulus, all these negative values would become the positive values, right? And all of them would be greater than 1. But for 2, it's the opposite. It's modulus r less than 1, which has the same condition in sum to infinity. Okay, so since it has the same condition, then we are going to use the second formula. Alright, so now we need to see what are the differences between these two and how from this formula will become this formula. Alright, so the main difference is only one, which is the thing inside the bracket here disappears, right? So we need to see how did Rn change, r to the power of n here change when s becomes infinity, right? Because just now we have mentioned that s infinity is a special case of Sn. Alright, so here let us change the value of n to be very, very big. Okay, of course we cannot put infinity, so let's put a big value later. Alright, and for the value of r here, let us use the example of r that I shown just now, which is 0.5. Okay, 0.5. So let us say for the value of n, okay, so let's say we start small first, right? So the value of n is power of 5. So if 0.5 is power of 5, we will get 0.03125, right? And now our n value, we need to go bigger, right? So let's say now it's 20. Oh, sorry, I think it's a bit too big. Let's say 10, right? So let's say we go to 10. So it would be around 0.0098. And if we use n as 20, right, I double up the value of n, so you can see it becomes even smaller, right? 0.00095. And if I double up the value of n again, I put 40, you can see that the value is very, very small already. All the first values are all zeros. This means when n goes to infinity, the Rn here will approach 0. Okay, so if you imagine, if this r to the power of n goes to 0, basically it's 1 minus 0 already, which is actually 1, and 1 I multiply with a is actually a. Okay, so this is why, how did the Rn suddenly disappear? Okay, because the value of n, if we make it to be bigger and bigger, the value of Rn would be approaching to 0 and eventually would be 0. That's why the entire thing disappears and the numerator here is just a. Okay, so now we have all of these things. How are we going to prove it? What is our workings? Okay, so first thing first, we need to state what is the formula of Sn we are using, which is this one. Okay, and just now we have mentioned that when s equals to infinity, and if we use this condition, right, this condition here, modulus r less than 1, what will happen? The Rn will approach to 0. Okay, let me rub off a bit, sorry. Right, just now we've mentioned that if the n approaches to infinity, which is the value 5 here, 10, 20, and then 40, and the value of r here, we are satisfying this condition, right, 0.5, so we need to write out this, the r condition, then the r to the power of n will approach to 0. So we need to have these two things in place, the condition of n and the condition of r. So Rn will approach to 0. So if this is the case, then in our working, we can change the Rn here to be 0. And then we can just show that the value of S infinity, the formula of S infinity is a over 1 minus r. And don't forget the condition at the back. And for part B, we are given a geometric progression, and it says we need to find out the sum to infinity. Okay, so this is sum to infinity of the progression in terms of x. So it means in our final answer, there will be x. Okay, so since we've already proven the sum to infinity formula, so let us use this formula straight away, right, to find out the sum to infinity. So here, we just need to find out what is the value of a and the r here. So a is the first term, meaning the first value in the progression here. So a is actually x, right? And for the value of r, we can just select either one of the values in this progression. So let's say I use this one, negative 2 over 3x. And to find out the r, I just divide with its previous value. Okay, so means negative 2 over 3x divide with x. Okay, so we can cross off the x here, then we can get the value of r already, negative 2 over 3. And once we have the a and the r, we can substitute inside this formula, something like this, and to find out the answer, which is 3 over 5x. Right? As you can see, our answer, there is x inside. Question 4 focuses on differentiation, and here we are given a point R which lies on this curve. So since this question didn't really give us a diagram or a graph, so why not we draw that graph here by ourselves, right? To understand the question better. But of course, we don't need to draw it to be very exact lah. Just a rough idea how will be the graph look like. Okay, so let's start off by plotting the point R here. So the x coordinate is 1 and the y coordinate is negative 1. So it will be here and the point R would be somewhere here. Okay, and for the curve here, so if you look at the curve's equation, it's actually a cubic curve. But for cubic curves, we are not really sure how does the shape look like. So what I'm going to do here is I'm just going to draw a curve or a line which intersect point R. Okay, because here it says the point R lies on the curve, right? So it would be on the curve, but it's just that we don't know the shape. So we are just going to draw a line or a curve here. Okay, so in part A, we need to find out the gradient of the tangent to the curve at point R. So let us recall back what is tangent. So tangent is a line that intersects one point of the curve, right? So now that one point is point R, right? Because here it says tangent to the curve at point R. So we are going to draw a line here that intersects point R. Okay, so now we need to find out the gradient of this tangent. So one of the ways to find the gradient is if we have 2 points on this tangent, and we can use the gradient formula to find out the gradient, right? But here we don't have those 2 points. So what are the other ways? So the other way is the things that we have learned in this chapter, differentiation, which we have learned about the gradient function. Right? So if we want to figure out the value of m, the gradient, we need to find out dy over dx value. Okay, the value of dy over dx. So what we need to do is let us differentiate this equation, figure out dy over dx. Okay, so let us differentiate this equation. So for this one, what we are going to do is we are going to copy the power to the front. So there will be a 3 in front. Alright, and the things inside the bracket, I'm not going to do anything. It will remain as it is. And for the power here, we are going to minus 1. So here will be 2. But that's not all. So this one would be a common mistake in students, which is students forgot to differentiate the things inside the bracket. Okay, forget to differentiate the things inside the bracket. So we need to do that. Right, so what I'm going to do here is I'm going to split the things inside the bracket by its plus or minus. Alright, so here we do differentiate two things, the 3 and negative 4x. So 3, if we differentiate, this 3 is a value, so it will be 0. And here it's negative 4x, there's an x only, so means once I differentiate, there will be the value only, which is negative 4. Okay, so here once we differentiate, it's negative 4. Right, and for negative 4, where should I put it? Well, we should put it at the back of the bracket here. Okay, so for this part, a lot of students will forget, so please make sure to remember this, to differentiate the things inside the bracket. Okay, so now once we differentiate the equation already, the result would be something like this. Okay, negative 4 times 3, it will be negative 12 here, and the things inside the bracket does not change. Alright, so now we are finding the value of m, right? But as you can see, there's an x here. We are not finding the expression, we want a value. So for the value of x here, we can just look at the gradient of which point we are looking at, which is point R, right? And point R, it has its own coordinates, which is 1 and minus 1 here. So for the x here, means that we can use the x coordinate of point R, which is 1. Okay, so to find out the gradient, I'm just going to substitute x with 1, which is the x coordinate of point R, and we can find out the gradient, which is negative 12. And for part B, we need to find out the equation of normal to the curve at point R. Right, so let us recall back what is normal. So normal is actually a line, but it is perpendicular to the tangent. Alright, perpendicular to the tangent. So now here it says normal to the curve at point R. So means that if you want to draw the normal here, it needs to pass through point R, and it needs to be perpendicular to the tangent here. Okay, so perpendicular, we know that it is 90 degrees. So if you want to draw the normal line, it would be something like this. Right, passing through point R and perpendicular to the tangent. So normal is a straight line, and like every other straight line, if we want to find out the equation, we can use y equals to mx plus c. Alright, so for the x and the y would be the coordinates of the points which are on the line, which we do have already, right? Because there is one point which is on the normal line, right? Which is 1 and -1. So we can just substitute the coordinates inside here. And how about the m? Okay, so the m here, right? So we do know tangent and normal are actually perpendicular to each other. And we have also learned in Form 4 Chapter 7, the coordinate geometry chapter, if we multiply the gradients of perpendicular lines, it would be equal to -1. And we already know the gradient of one of the lines already, which is the gradient of the tangent, which is also the answer that we have got in part A. So we can use this formula and we substitute the value inside here. So once we substitute, we can find out the gradient of the other line, which is the normal. Okay, so let's do that. So for the -12, I'm going to substitute inside here, and we move the -12 to the other side. We can find out the gradient of normal, which is 1/12. So now we have the x, the y, and the m. So let us substitute all of the things here to find out the c value, right? The y-intercept value. Okay, so x is 1, y is -1, which is the coordinates of r, and m is 1/12. So c here would be -13/12 once we adjust the equation here and there. Okay, so once we have the gradient and the y-intercept, we can form the equation already. So it would be y equals to 1/12x minus 13/12. Next question focuses on quadratic functions, and in part A, we need to use this table method, alright, the table method to find out the range of values of x from this quadratic inequality. Right, so if you see range in the question, means that in our final answer, there will be inequalities, which are the greater than or the lesser than symbols, right? So you see this in our final answer later. So now the question tells us to use the table method to solve the quadratic inequality. But in fact, there are also other ways to help us solve quadratic inequalities. So in total, there are actually 3 ways. So the first way is using the graph method, which we use all the time, and it's the fastest way. So it's usually, we draw a curve here, and then we draw an x-axis here, and then from the condition of the quadratic inequality, okay, quadratic inequality here, we see which are the regions that satisfy the criteria. So it's either these two sides or the region between it. And we can find out the answer. So this is for the graph method. The other method is called the number line method. Right? So same thing as graph, it's just that now it's at a number line. Okay, so number line I split into 3 parts, and each of the part has its own x values. So we need to see for the x values, if we substitute inside the quadratic inequality here, does it satisfy the criteria? Right? So this is the number line method, and the last method would be the method the question is telling us to do, which is the table method, which I will show you all later. Alright, so if you want to see some examples of solving quadratic inequalities using the graph method or the number line method, you can look at the other video that I have done this year, which is this year's trial paper for KEDA, paper 1, question 14. Okay, so I will be putting the link here now, as you can see here. Alright, so you can click into this link and you will direct you into the video there. Alright. Okay, so now let me show you how do we use the table method to solve this quadratic inequality. So before we use the table method, first thing first, let us find out the two values of x from this quadratic inequality. Okay, so how are we going to do that is to use the factorization, right? We can use the factorization way by using the calculator to find out the two values of x, which is x plus 1 and x minus 5, or meaning x is negative 1 and positive 5. Alright, so now we have factorized our quadratic inequality, then we can go to the table method. So to draw out the table, let's draw out a 4 times 4 table. So we have 4 rows and 4 columns. Okay, so now we to know what should we put at the columns, what should we put at the rows. So for the columns here, we are going to put all possibilities of x, okay, according to our x values here. So in total, there will be 3 possibilities. So the first possibility would be the x values which is less than negative 1. Right? All the values which are less than negative 1. The second possibility, it would be the values between our two x values here, negative 1 and 5. Then the last possibility would be the x values which is greater than 5. Okay, so this would be our 3 possibilities of x according to our two values of x here. And for the columns, we are going to put parts of the inequality here. Okay, so for the row here, what I'm going to do is to put this part of the inequality here. Alright, and for the next row, I'm going to put this part of the inequality here. And for the final row, I'm just going to combine both of these things into here. Alright, so now we have set up our columns and the rows. Okay, but we still don't understand how does it work. Right? Okay, so let me use the first possibility of x as an example. Okay, so let's say here, let me choose a value which is less than negative 1. Okay, let's say is negative 3. Alright, negative 3. So what we are going to do is, we are going to substitute the value here inside each of the rows here and to see whether it is positive or negative. Right? We don't need to put the values, we just need to put whether it is positive or negative here. Right, so let me give you an example. So negative 3 put inside here, so it's negative 3 plus 1, which will be negative 2, which is a negative value, right? If we substitute negative 3 inside here, here will be negative 3, negative 5, which is negative 8, so it's also a negative value. Okay, for the last row, actually we don't need to do it. We don't need to substitute negative 3 inside, because these two things, we have already found both of them are negative. So if we imagine, if we multiply negative and negative, it would be positive, right? Okay, so for the last row, actually we don't need to calculate already, because we can depend on these two results to find out the result here. Okay, so the final result would be looking at this row. So here, back to our inequality here, if let's say it is greater than 0, because this is actually our condition, when we multiply, it must be greater than 0, meaning it must be positive. So if we see here, it has a positive value, which we have now, which we are seeing now, right? So this value, x less than minus 1, would be our answer, because it is positive. Alright, so we need to see in our final row here which columns here says positive. If it's positive, then it would be our answer, because now we are trying to find the range of values of x that is positive. Okay, so this is how it works, right? So now let's set values for each of the columns here and use the same way to find out whether it is negative or positive, right? So for the second column here, let me use 3. Alright, so 3 I put inside here. 3 plus 1 would be 4, which is a positive value. 3 I substitute inside here, so 3 minus 5, it is a negative value. So if I multiply these two results, positive, negative, negative. Alright, and for the last column here, so let me put 6. So 6 I substitute inside here, so 6 plus 1 is 7, which is a positive value. And 6 I put inside this value here, it would be 6 minus 5, which is 1, which is also a positive value. So positive, positive, positive. Alright, so let us look whether each of the columns here, whether it satisfies this criteria, which is positive. Okay, so here we do see, here it's positive and here is positive, so means our range of values of x would be this one and this one. Okay, so this would be our final answer. X is less than minus 1 or x is greater than 5. For part B, it says that alpha and beta, okay, so this is called alpha, A-L-P-H-A, and beta, B-E-T-A, are the roots of the quadratic equation. Oh, it's a bit cut off here, but you can look at here, right? 2x squared plus hx minus 2 equals to 0. And now we need to form a new quadratic equation with the roots of 1 over alpha plus 1 and 1 over beta plus 1. And we need to write it in terms of h. So means in our final answer, there will be h. Right? But notice it doesn't say in terms of alpha, beta, and h. So which means the alpha and the beta here, later on we need to change it into values. Meaning our final answer cannot have alpha and beta. So now we have the roots given and we need to form a quadratic equation. How do we do that? Right, so we need to recall the things that we have learned in this chapter. So one of the things that we have learned is the SOR and the POR. SOR is sum of roots, POR is product of roots. So sum of roots is basically the value when we sum up these two values, and the product of roots will be the value if we multiply these two values. So once we have the SOR and the POR, then we can form an equation according to here, right? X squared minus the SOR and multiply with x plus the POR and equal to 0. Alright, so now we need to figure out the SOR and the POR. Okay, so since we have the roots here, so let us do that. So SOR, it would be to add up these two fractions. Alright, and if we want to add them up, we need to have the same denominator. So for the first fraction here, I'm going to multiply the value of the denominator at the second fraction here, right? Beta plus 1. Okay, so above and below multiply the same value. So it would be something like this. And for the second fraction here, I am going to multiply the denominator of the first fraction here, which is alpha plus 1. Alright, alpha plus 1. Okay, sorry, here should have a bracket here. Okay, so if I multiply, it would be something like this. So now we can see that the denominators are the same, so we can combine these two fractions. Okay, so the numerator here would be adding up these two values, so it will be something like this. And for the denominator here, we are going to cross multiply. So alpha multiply beta, alpha multiply 1, 1 multiply with beta, and 1 multiply with 1. Okay, so this will be the result. So now if we tidy up the things here and there a bit, so this would be the simplified version of the fraction. Okay, but if this is the simplified version, there is still alpha and beta here. And just now we have mentioned that for the alpha and beta, it must be changed to values. Alright, so how are we going to find the value of alpha and beta? Okay, here we actually didn't use this equation yet. And now it will be the best time to use it because this equation is a quadratic equation and it also follows this rule. Alright, so it will be useful for us if we can find out the SOR and the POR in two ways. Alright, so the first way is we look at the alpha and the beta here, because here it says alpha and beta are the roots of the quadratic equation. Okay, so from the alpha and the beta, let us find out the SOR and the POR. Right, so SOR would be adding up these two values, right? So it would be alpha and beta. And for the POR, it's just multiplying the alpha and the beta. Okay, so this is the first way of finding out SOR and POR. Now, the second way is we can use the quadratic equation here. Alright, so let us put it down here. And from this quadratic equation, let's change the equation here and there a bit so we can compare and find out the value of SOR and POR according to here. Okay, so let's compare the first value here. So there is x squared, but here we have 2x squared. Okay, so this is a thing students will always forget, which is we need to make sure the value of x squared here is 1. Alright, so from 2, how do we change to 1? Very simple, it's just divide the entire equation with 2. Okay, so the value of x squared here would be 1 and the rest of the values here would be divided with 2. Okay, so now here is the same already. So if you compare here and here, actually we can find out the SOR and the POR already. Okay, so now if we want to find out the SOR, it's the value of x. So it would be h over 2. Not correct. Here it's negative. Okay, but why is it negative? Alright, so if you look back at the equation here, right, in front it is negative, but here it is positive. Okay, so for the positive here, we need to split it out. So negative, negative, positive, right? So we are going to split this positive into two negatives. Alright, and this negative, let us attach it to h over 2 here, and there would be a negative outside. So why we need to split this positive into two negatives? Because we need to match it to here. Okay, since there's a negative here, so I need to have a negative outside. So once I have a negative outside, the x value here would be negative h over 2, right? To compare with the equation here. So our SOR here is negative h over 2. So this is also one of the things students will always forget. If we want to figure out the SOR, alright, so for example just now, right, there's actually an easy way to do this. Okay, so if we want to find out the SOR from an equation, what we need to do is just, if you see it's a positive value, we change it to negative. If we see it's a negative value, we change it to positive. Alright, so for this case, it's positive h over 2. So once we extract the SOR, it would be negative. Alright, so another example. Let's say the equation is x squared minus 3x minus 1. So if you want to find out the SOR, it would be 3. Okay, from negative, we change to positive. Alright, so here from positive, we change it to negative. And for the POR, it would be the value that does not have x, which is actually negative 1. So our POR would be negative 1. Okay, so this one we don't need to change the sign, because if we split this negative to have positive, right? Okay, if we split it, yeah, it's still positive negative, right? The 1 is still a negative value. Okay, because here it's positive. So this one, we don't need to change the sign. It will remain it as negative. Okay, so now we have used two ways from this equation to find out the SOR and the POR, and then we can equate both of the things here. Right? So means alpha plus beta, it would be negative h over 2, and alpha beta would be minus 1 or negative 1. Okay, so now according to our two results here, let's go back to our fraction here. Okay, so now if you compare here and here, you can see there are some similarities already. Okay, so here you will see alpha plus beta, which is actually the SOR, right? The SOR. So means for these two things, we can change it to negative h over 2. And here you will see a alpha and beta also, right? So this value, we can change it to negative 1. Okay, so this would be the result once we have done that. Okay, so now you can see everything is h already. There are no alpha and beta anymore. Alright, so now let us simplify the things at the numerator and the denominator. Okay, so if we want to combine the things in the numerator, we first need to change this value into a fraction first. And let's use the denominator here, which is 2. Alright, so what value divide with 2 will get 2? 4, right? So for the 2 here, it will transform into 4 over 2, and we can add with this value here because it has the same denominator already. So here will be 4 minus h over 2. And for the denominator, because there's a negative 1 and a positive 1 here, so if we add them up together, it basically will cancel off because it will become 0. So here we have left with negative h over 2. Alright, so now let us divide these two fractions. Okay, so let me pull this to the top. So here will be divide negative h over 2. Alright, but of course we cannot divide a fraction, so we need to change this into multiply, and we need to change the positions of the fractions here. Alright, so here you can see that we can cross off the 2 here. So we have left with negative 4 minus h over h. Okay, and for the negative here, let us apply it into the numerator here. So means 4 will become negative, h will become positive. So it would be this result, h minus 4 over h. Okay, so this is just for the SOR part only. We still need to figure out the POR part, alright, which is to multiply these two values. Okay, so here, because SOR we did a lot of things, so let us see whether if we multiply alpha plus 1 and beta plus 1, did we already found it in SOR? Okay, so if we look at here, actually we are already done, right? Alpha plus 1 multiply with beta plus 1, which would be this result, right? And then if we simplify the thing, it is actually, okay, here, it is actually negative h over 2. Alright, so since we are multiplying alpha plus 1 and beta plus 1, we can just take the final result that we have gotten in SOR. Alright, so to change it to negative h over 2, oops, sorry, it's not this one, it's this one. Okay, because I already crossed off this one, so basically you cannot see, but we can see it here. Okay, so it's negative h over 2. Okay, we don't need to do the working again because we have already shown it in SOR. Right? You won't be deducted marks for this. Okay, so for the negative h over 2, because it is under a fraction, so we can pull it upwards. So basically the 2 and the h switch places. So it would be negative 2 over h. Okay, so now we have the SOR and the POR already. So to form the quadratic equation, we can use this result. Alright, so x squared minus the SOR, and we have an x here, and plus the POR, which is plus the value here. Okay, and since there is a denominator for h here, right, so let us multiply the entire equation with h. Okay, so we can cross off the h here, and the x squared value, there will be an h here, so the final answer will be hx squared minus h minus 4x minus 2 equals to 0. Question 6, going back into circular measure. So there's a few information describing the diagram here. So let's go through them one by one. Alright, so we have a rectangle here, and it's A, B, C, D. Alright, and then they gave us the measurements of the lines. So AB here is 5 cm, BC here is 16 cm, and it also says that O is the midpoint. Okay, so this is the midpoint of BC. Okay, so O is the middle point, which means that the length of these two lines, BO and OC, are the same. So if you want to find the length of one side, very simple, it's 16 divided by 2, which will be 8 for each side. Okay, and for the shaded region here, as you see, it is touching the center of the circle, which means this shaded region is actually a sector. Alright, so in part A1, we need to find out the length of AO. So AO is this line. So just now we've mentioned that this shape is actually a rectangle, which means the angle for the rectangle here are all 90 degrees. Right? 90 degrees. So this means that this line is actually part of the right angle triangle. Okay, so if we know it's a right angle triangle, we can use Pythagoras theorem, right? Because we need to find the length of one side of a right angle triangle. Okay, so to use the Pythagoras theorem, very simple. So AO will be equal to the length of both sides, and we need to square them. So it's 5 square and 8 square, and then we sum them up together, and we need to square root. Right, so once we put this into calculator, the square root value would be 89, and if you want to find the decimal, it would be 9.434 cm. Right, so this is the decimal format. This is the square root format. And for part 2, we need to find out the angle AOD, which is here. So let me put this as theta, right? So we need to find out theta, and we need to write it in radians. Okay, so let us take a note here. We need to write it in radians. Alright, so to find out the theta here, what we need to do is to see the angles which are beside it, which is here and here. These two angles. So why I look at these two angles is because if you combine all of these angles together, it is like a half a circle, right? Or meaning half a turn. So if it's half a turn, we know that its angle, right, which is 180 degrees. So meaning if we want to find out the angle AOD, it would be 180 minus out these two angles here. But if you notice, these two angles should be the same because they are coming from similar triangles with similar lengths. So we know that this entire thing is a rectangle, right? So the length here, AB, is 5, meaning CD is also 5, right? So as you can see, these two triangles have the same length, 5 and 5, and the same width here, 8 and 8. Okay, so these two angles should be the same, so it would be 180 minus out one of the angles, and I multiply 2. Right? So here I'll be writing -2 angle AOB. So angle AOB is here. Alright, so now if you want to find out AOD, we need to figure out AOB first, which is here. So how do we find out this angle? So since this is a right angle triangle, to find out the angle, we actually can use the trigonometry way, right? Which is the sine, cos, and tan. So here, if you want to use sine, cos, and tan, we need to see for each of the lines here, what are they? Are they the opposite, adjacent, or hypotenuse? Right? So once we know each of the sides is opposite, adjacent, or hypotenuse, we can see which trigo function to use, and then we can find out the angle already. Okay, so if you look at this line according to the angle here, it's the opposite, right? This line is the opposite of this angle, so it's O, and this line is actually the adjacent, right? Because the hypotenuse is here, AO. So since we have the lengths of O and A already, so why not we use these two? Okay, so O and A. So O and A is actually tan, right? Because tan is opposite divided by the adjacent. Okay, so if you want to find out tan of this angle, which is tan AOB, it would be opposite, which is 5, divided by the adjacent, which is 8. Okay, so if we move this tan to the other side, so it's arc tan, right? So this is not called arc -1, it's called arc tan. So arc tan 5/8. If you put into the calculator, you will get 32.01. Alright, so let's put this value inside our working here, and we can find out the angle of AOD already, 115.99. But this is not our final answer because we need to write it in radians. Okay, so to change it into radians, what we need to do is to do two things. First thing is to multiply pi. Second thing is to divide with 180 degrees. Alright, so for the pi, please make sure to not use the pi in the calculator. Please use the value which is given here, 3.142. Alright, so in our working, yes, we are writing pi, but when we type into the calculator, please type 3.142. Okay? So once we multiply this value and divide with this value here, you will get the angle in radians, 2.0247. And this is a standard way of writing out the angle in radians, which is to write it in 4 decimal places. Right? 4 decimal places. And for part B, here it says hence. So hence means that we can use the answers we have gotten in part A to help us in part B, right? And we need to find out the perimeter of the shaded region. So to find out perimeters, first we need to identify the lines of the shaded region. Okay, so let's start off with point A. So the first line would be line AO, and line OD, and then this line here, which is called the arc AD. Alright, so to find out perimeter, we need to find out the length of these three lines. So let's start off with AO. So AO, we actually found out in part A1 just now, right? Which is 9.434 but here I will be using the square root format answer, which is square root 89. Okay, reason is because square root 89, if we use square root 89, it would have a more accurate answer for our final value compared to 9.434. So why I use square root is because it has a more accurate answer later on. Alright? For OD is here, and since OD is in a triangle which is similar to the triangle here, so meaning AO and OD are actually the same. Alright, so OD would be also square root 89. And the arc AD, how do we find the arc length? So we look at our formula sheet, formula 27 and 28. So arc length, it would be from formula 27, and it would be S equals to R times theta, the radius times the angle. Right, so R here is the radius of the sector here. So since this is the sector, which means the radius would be this part, which is also OA, which is also square root 89. Alright, and for the theta here would be the angle of the sector, which is this one, which we have also found out, which is 2.0247. Right, so please make sure to use the radians format. Do not use the degree format, because again, these two angles are using the radians. Alright, so we are going to use this value into our working here, 2.0247. So now we have found out the length of all the sides here, so we just add them up together to get the final answer, 37.97 cm. Question 7 focuses on vectors, and here we have two vectors given, which is vector u and vector v, and inside these two vectors we have other vectors which are vector a, b, and c. Alright, which the values are already given here. So there is actually a name for the form of the vectors here. It's actually called the column vector format. So if you see the values, it is actually on top of each other. So you may be asking, what does the value of x and the value of y here represent? Okay, so actually the values of x and y are the value of vector I and vector j. Alright, so let us recall back what does vector I and vector j represent. Right, so vector I would be the number of steps that we go to the left or to the right. Okay, so if the x value here is positive, we are going to the right. If it's negative, we are going to the left. So for vector j, it would be the number of steps when we are going up or going down. So if the y value here is positive, means that we are going up. If the y value is negative, it will be going down. Alright, so if we use this vector as an example, so the value of x here is a positive 3, so means this vector moves 3 steps to the right. And for the y value here is 4, means this vector goes 4 units upwards. Alright, so now in part A, we need to figure out the vector u. Okay, so we do know the vector u here is vector b minus vector a, and we already know the value of the vectors. So this one very simple. We are just going to substitute inside the equation here, minus them together, and find out the vector, right? Which is 2 and 3. And for part B, it says if vector u is parallel, alright, parallel to vector v. For the first part, we need to figure out the value of m, which is actually the value of vector c here. Okay, so if here says parallel, what do we need to do? Right, so this is a very important word in vector, because if we see parallel, means that we can use this result. So this equation means if let's say I have two parallel vectors, which is vector AB and vector CD, but I do not know the vector AB, but I know the vector CD, right? So to find out AB, very simple, it's just the parallel vector multiply with a value to get AB. Right? Very simple. So the value here is called lambda, Lambda, and it's just a value. Alright, so going back to here, it says U is parallel to V. So what we can do is, for the vector U here, I'm going to put into vector AB, and we're going to remain the lambda here. And for the vector V, I'm going to put into vector CD. Alright, so let's use this equation to find out the value of M. Alright, so first thing first, we need to have the values of the two vectors here. So vector U, we already done it in part A, but for vector V, we still haven't done it yet. Okay, so let's find out the vector V first. So to find out vector V, it will be finding the difference between these two vectors, vector C and vector B. So we substitute the values of the two vectors inside here, find the difference, and this would be the result, m minus 5 and negative 4. Alright, and I'm going to substitute it inside this equation. Okay, so now for the lambda here, I am going to multiply into the vector here. And what we are going to do is, we are going to compare the values on top and the values at the bottom. So why we do this is because we can find out the value of lambda and m. Okay, so according to these two equations, I think we can solve this one first, because we can find out the value of lambda straight away, right? It's just moving this negative 4 to the other side, which lambda will be equal to negative 3 over 4. And then I substitute this value inside here. Then we can have this result. So basically this lambda is moved into here, negative 3 over 4, and m minus 5 here. So for this negative 3 over 4, I'm going to move it to the other side. So means we are going to divide with 2. And once we've done that, we are going to move this negative 5 to the other side. So means plus 5 once we move to the other side. So once we've done that, we can find out the value of m, which is 7 over 3. Okay, so now in part 2, it says hence we need to find the ratio of this thing. Right, so why are there modulus at the vectors here? Okay, so these are actually not the modulus, these are actually called the magnitude. Right, so in vectors, if you see there is two vertical lines beside it, these are called the magnitudes. So what are magnitudes? Magnitudes is the length of the vector. Alright, so how do we find the length of the vector? Basically, we can use this formula. So square root x squared plus y squared. Right, and the x and the y, how can we find it out? Is actually the values of the column vector here, which is the x and the y here, which is also the value of vector I and vector j. Okay, so here let us find out the magnitude of vector u and vector v first. Okay, but first, for vector v, we still don't have the final vector yet, because we still haven't substituted the value of m inside the vector here. Okay, so let's do that. So here we substitute, here it would be 7 over 3. So once we simplify, it would be negative 8 over 3 and negative 4. So now we have the values of vector u and vector v already. So let's use this formula to calculate the magnitude of vector u and vector v. Okay, so for the values of x and y, which is 2 and 3, substitute into the formula. Negative 8 over 3 and negative 4, substitute into the formula. But let us not calculate the actual value of this square root, let us remain the square root first and we simplify the values inside the square root. Okay, so meaning we put the calculator with 2 square plus 3 square, we will get 13, and we remain the square root first, right? And for vector v, once we put this thing into the calculator, it will be 208 over 9. Okay, so why we remain the square root is because we want to find the ratio later. If we change it into decimals, it will be a bit hard, right? So now, to find the ratio, what would I usually do is, I am going to divide these two vectors. Right? I'm going to divide these two vectors. Okay, later you'll see why. Right? So here, we are going to divide these two values, so means we are going to divide the two square roots here. Alright, so now let us put this square root into the calculator. Right? And then you'll find out the answer is 3 over 4. Okay, so this is why we remain the square root, is because we can find out an actual value for our ratio, which is 3 and 4. Alright, and why I divide is because we can compare the left fraction and the right fraction here. Right? So if we compare the values on top of both fractions, you can see that the magnitude u is actually 3 parts. Right? The magnitude of vector v is 4 parts, which means the magnitude of u to v is 3 to 4. Okay, so this would be our ratio of the magnitudes of these two vectors. So you'll be asking, why is the formula of magnitude like this? Right, so let's use vector u as an example. Alright, so for the value 2 here, it is the value of x, which is also the value of vector I. So we know that if the value of x here is positive, means it is going to the right, and since this is 2, means we are going 2 units to the right. Okay, so this is 2 units to the right. And then the value at the bottom here is the value of y, which is also the value of vector j. So if we see the value y is positive, means that we are moving to the top, right? We are moving upwards. And here is 3, so means we are moving upwards by 3 units. Alright, so previously we were here and now we are here. So to find the length of vector u, basically is the distance from our starting point to the end point. So this is the vector u here. Okay, so now if you see, we combine these 3 lines here, right? These 3 lines here, it is actually a right angle triangle. So as we know in the previous question, if we want to find the length of one of the sides from a right angle triangle, we use Pythagoras theorem, right? Pythagoras theorem. So let's say now we are trying to find the length of vector u. So how should we do it? So what we will do is 2 and 3, which is the length of the lines here, we square them, we add them up together, and then we square root, right? So now you compare the working that we have here. It is actually the exact same thing. So means that this method, right, this formula is actually coming from Pythagoras theorem, right? So this is actually the Pythagoras theorem, right? So to find the magnitude of a vector, we are actually using the Pythagoras theorem. That's why this formula is like this. For question 8 focuses on coordinate geometry, and in part A, in this diagram, we are given a line segment AB. Alright, and is made up by 3 points here, A, C, and B, and we are given the ratios. So A to C is m parts, and C to B is n parts. Alright, so now we need to show that x is equals to mp plus mv over m plus n. Alright, so this thing is quite complex. So is it something that we have learned before? Actually yes, because if we look at this sentence here, point C divides the line segment AB. Right? So if you look at your formula sheet, there is one formula that mentions line segment or segment of the line. Alright, so actually we are trying to prove formula for D1, a point that divides a segment of a line. So this part is actually the x coordinate part of the formula here. So it's the x and this part of the formula here. Okay, so now how are we going to prove this? Okay, so here, since it is focusing on x coordinates only, so for the y coordinates here, let us just ignore it first. Okay, and here what I'm going to do is I'm going to draw this straight line again here. Right, we have the points A, C, and B, and we have the ratios here, which is m and n, and the x coordinate of A, C, and B, which is v, x, and p. So why we form this diagram is because, so here we have the ratio of the lines already, right, which is m and n. So what we can do is we can find out the lengths of the lines here, and then we can compare it with the ratio here, and we can form some equations. Alright, so for the length of AC here, because x is bigger than v according to this diagram here, right, because point C is here and point A is on the left of point C, right, so x is greater than v, so the length here is x minus v. And for the length of CB here, because p is greater than x, so it's p minus x. Right, so now with the length and the ratio here, we can form some equations. Okay, so for the first equation, let's focus on this one. Right, so this would be x minus v equals to m. Right, equals to m. And for the second equation, it would be p minus x equals to n. Right, equals to n. But here, because we have two equations, and if you see here, we need to show only one equation, so why not we form these two equations to become one equation? Okay, so how are we going to do that? Here, very simple, it's just forming fractions from both sides, and we put equal here. Alright, so this would be our equation. Right, because we see that x minus v, which is the length of AC, is m parts, and the length of CB, which is p minus x, is n parts. Alright, so let's now simplify this equation and let's change it into the formula that we are trying to prove here. Alright, so let us cross multiply the values. So meaning n, we are going to multiply with x minus v, and for p minus x, we are going to multiply with m. Right, so this would be the working. And now we are going to multiply n inside this bracket here and m inside this bracket here. Alright, so the result would be something like this. Alright, so now let's go back to our formula that we are trying to prove. So here you can see that x is on the left side of the equation. So means everything which has x, we need to move it to the left side. Everything that does not have x, move to the right side. Okay, so this negative mx, we need to move it to the left side. And for negative nv, because it does not have x, we are going to move it to the right side. Okay, so this would be the result. So negative mx move to the left side, it will be a positive value, and this negative nv move to the other side, it will be a positive value. Alright, so now we just want to have x on the left hand side, so what we are going to do is factorize the x from the two values here. Alright, so it would be something like this. And then we are going to move this n plus m to the right side because there's no x anymore. So we're going to move it to the right side, and you can see that we have proved the formula already. Alright, mp plus nv over m plus n. Okay, so make sure that your final working here is exactly the same as the formula shown here. Alright, for part B, we have a line PQ, which is actually the tangent to the circle. Alright, so this is the tangent, and if we recall back what is tangent in the previous questions, it is a line that intersects one point of the circle or the curve. So for this time, this line intersects at point P. Okay, and we have the coordinates of point P here, which is -2, 4. And we also have the coordinates of the center of the circle, which is point K, and the coordinates is 2, -1. Alright, so now we need to find out the equation of tangent PQ. So tangent is a line, and like any other line, we can use the y equals to mx plus c to find out the equation. Alright, but this time we need to write it in the general form. Right, so what is the general form, and is y equals to mx plus c the general form? Right, so actually y equals to mx plus c is called the gradient form because it has a gradient here, the m. Right, so this is not the general form. General form is actually this. As you can see, the right side of the equation is 0. So you may be asking, how do I get the general form? Is that the case? Well, we actually can use the gradient form. Alright, we can use the gradient form. It's just that once we found out the y equals to mx plus c, we are going to move everything to the left side. Alright, everything to the left side, so the right side will become 0, which is the form of the general form. Okay, so once we have the gradient form, we are going to move everything to the left side, so right side would be 0, and this would be the general form. Okay, so before we find the general form, let us find out the gradient form first. Alright, so here for the x and the y value would be depending on the coordinates of the point which is at the tangent, which we already have, which is the coordinates of point P, right? Because P is at the tangent, right? So our x would be -2 and our y would be 4. Okay, so that's for x and y. How about m? Okay, the gradient of the tangent here. Okay, here we only have 1 point. We don't have 2 points, because if we have 2 points, we can use the gradient formula to find out the gradient, right? But here we don't have. Okay, so we need to recall back another thing for tangent. Right, so if we have a tangent to the circle, tangent is actually perpendicular to the radius of the circle. Right, the radius of the circle, which is actually this PK. So means the tangent and the line PK here are perpendicular to each other. Right, so since both of them are perpendicular to each other, and if we want to find the gradient of the tangent, we can use the formula that I've mentioned in the previous question also, which is the gradients of two perpendicular lines. If we multiply them together, it will be equal to -1. So means if let's say m1 here is the gradient of the tangent, alright, and if we can find out the gradient of line PK here, right, if we have the gradient of line PK here, we can use this formula to help us find back the gradient of line PQ. Okay, so now let's see if we can find out the gradient of line PK. Alright, so in this line, we have 2 points that has the coordinates. Okay, so this means if we want to find out the gradient of PK, we can use the gradient formula. Alright, which is the y1 minus y2 over x1 minus x2. Okay, so for the coordinates of point P here, so let us use this as the first point. So y1 minus y2, so it's 4 minus minus 1, and over x1, which is -2, minus x2, which is 2. Alright, so once we simplify, then we can get the gradient of this line, -5 over 4. And now we can substitute inside this formula here to find out the gradient of PQ. So we move this to the other side, meaning divide with -1, then we can get 4 over 5. Alright, so now we have the x, the y, and the m. So how do we get the value of c? Okay, so we can substitute the coordinates inside here and the m value inside here to find out the value of c. Okay, so once we change the equation here and there, we can find out the value of c is 28 over 5. Right, so for our equation of tangent, it would be this result. Y equals to 4 over 5x plus 28 over 5. Alright, so we are not done yet. We need to change it into the general form. So what we need to do is to move everything to the left side first to make sure the right side is 0. Okay, so this one we put it to the left side, it will be negative. This value, if we put it to the left side, it will be also negative. Okay, and what we are going to do here, so there's fractions here. So usually for general form, it don't have fractions. Right, it don't have fractions. So what we are going to do is we need to remove the denominators here, which we are lucky because here both of them have the same value. So what we are going to do is just multiply 5 for the entire equation here. Okay, so the 5 here will cross off for these two values. For the y here, we'll multiply with 5. And another thing to take note is this value of a, make sure it is positive. Right? Make sure it is positive. So now we have a negative value of x. So what we are going to do is to multiply the entire equation with -1. Or meaning, change the values which are negative to positive, positive to negative. So the two values here, which is negative, will change to positive, and the value here, which is positive, will change to negative. And this would be the general form of the equation of tangent PQ. Question 9 focuses on integration, but in part A, there's a bit of differentiation inside of it. So this is like a differentiation and integration, that kind of question. Right? So in part A, we are given the equation of y and the equation of dy over dx. So now it tells us to find the expression once we integrate this thing, and it needs to be in terms of x. Alright, so to understand this question, let me draw a flow diagram first. Alright, so we know that if we have y and if we differentiate it, we will get dy over dx, right? And from dy over dx, if we want to change it back to y, we integrate. Okay, so let me change the y and the dy over dx according to the expression given here. Alright, so this means that if we differentiate this thing, it will become this, and if we integrate this, it will become this. Which also means that if the question tells us to differentiate this thing, we can just straight change it to this expression. And if let's say the question tells us to integrate this thing, then it will be this expression. Okay, so now in the question it tells us to integrate this, right? This expression here. So since they are telling us to integrate, so we can just ignore the differentiation process here. We can just focus on the integration process. So again, if we want to use this thing, we first need to have this expression, and once we integrate, then we can have this expression. We can just straight change into this expression. So now in the integral here, we need to make sure the things are exactly the same here. Then we can only integrate. Alright, but if you compare, there's a bit of difference, which is the value of 3 and the value 12 here. So we need to change this 3 to be 12. So how do we do that? Okay, so here we can just multiply a value, because 3 times 4, it would be 12, right? So here we can just multiply 4 at the numerator part, so here it will transform to 12, and the entire thing in the integral here is exactly the same here. But of course, when we multiply 4 at the numerator, we also need to multiply something in the denominator, right? So here, we also need to multiply 4, right? The denominator will multiply 4. So the 4 would be somewhere here, but if we put the 4 here, right? If we put the 4 here, it's not the same anymore, right? Because there's a 4 here. So what I will do is, instead the 4 in the integral here, I'm going to move it out of the integral. So here would be a 4 here, which is also 1 over 4. And since the expression in the integral is exactly the same here, so once we integrate, it would change to this result. Alright, so it would be the integrated result here. Alright, and then we just multiply 1 over 4 inside to get the final answer. For part B, we are given the curve and also its tangent, which is intersecting at point A. And both of the lines have their own equations. So here we need to find out the area of the shaded region, which is here. Okay, so from here until the very top, reaching to point A, and then back here. Okay, so to find out the area of the shaded region, I will always recommend students to use either one of these two ways according to the question. Okay, the first way is big shape minus small shape, and the other is add up all the shapes that we can recognize. So to show big shape minus small shape, let me use this question as an example. So big shape will be the shape that we can recognize and includes the area that we want. Alright, so if we look at the area of the shaded region here, it's actually under the curve, right? Under the curve. So means if we want to include the shaded region here, we need to use area under the curve. Alright, but from where to where? Area under the curve from where to where? So you can see that this region starts from this line, right? When this line is where x equals to 0, right? X equals to 0, and it ends until at point A, right? So we can use the x coordinate of point A, which is 2. Alright, so the region, the big shape would be the area under the curve from 0 to 2. Okay, so this would be our big shape, the area under the curve from 0 to 2. But of course, we cannot just include the entire thing, right? Because here is not the area that we want. So this is where small shape comes in. Small shape would be the recognizable shape that includes the area that we do not want, right? We do not want, which is this part here. And if you can recognize, this is actually a triangle, right? So our small shape would be this triangle here. So to find out the area of the shaded region, it would be the area under the curve minus out the area of triangle. Okay? So this is how we use big shape minus small shape way. But how about the other way? Add up all the shapes. Alright, so let's say we have this shape, right? Above is a semicircle, below is a rectangle. So the first thing first is to recognize the shapes, right? So we are going to draw a line here, so we can clearly see that there is a semicircle on top and a rectangle at the bottom. And for each of the shape here, we are going to find out its areas according to the formulas that we have learned. Alright, so once we recognize the shapes, we find out the areas, then we add up the area for the shapes here. Okay, so to recognize the shapes first, find out the areas, and then add up the areas for all the shapes. Okay, so this is how we use add up all the shapes. So coming back here, let's find out the area under the curve and the area of triangle. Alright, so to find out the area under the curve using integration, we have two ways. Either we use the x-axis way or the y-axis way. So which axis to choose, we need to see which axis bounds the area under the curve. Right, so let me go back a bit. Right, let us see the area under the curve. So just now we have seen that this shaded region, right, it is below this curve, right, below this curve. So this area here, actually it can go beyond the x-axis, but since it is bounded by the x-axis here, it is controlled by the x-axis here, so the area under the curve only stops at the x-axis. Okay, which means this area here is bounded by the x-axis. Alright, so means here between x-axis and the y-axis, we are going to use the x-axis way. Okay, because it is bounded by the x-axis. Okay, so to start off, we are going to put the integral at the front and dx at the back. Why we use dx is because we are using the x-axis way, right? And for the value of a here, so a here is the lower limit, which would be the lowest x value in this area under the curve, which we already found out, which is 0. Alright, and the value of b here is the upper limit, which is the highest x value in this area under the curve, which is 2. Okay, and for the y here, the y is using the curves equation, because we are now finding the area under the curve, so we do use the curves equation. So it's 1 over 2 x squared plus 1. And for the area of the triangle, we can use the formula that we have learned previously, which is 1 over 2 times the base times the height. Right? So here will be 1 over 2, and for the base, okay, base it would be from here to here. So we know the value here already, which is 2, but here we don't know. Alright, so since this line is intersecting the x-axis here, so why not we find out the x-intercept of this line, right? Which means the y would be 0. Okay, because we are finding out the x-intercept, right? So if we change the equation here and there, and we can find out the value of x, which is 1 over 2. Okay, so here it's 1 over 2. So if we want to find out the length here, it would be 2 minus 1 over 2. And for the height here, right, so the height here we can actually use the y coordinate of this point, right, which is 3. So the height here is 3. Okay, so now for this one, let us integrate. But before we integrate, let me separate it by the plus and the minus here to see how many things we are going to integrate. Right, so here we have 2 things to integrate. Right, so first thing first, the power I need to add 1, and I'm going to divide with the new power, which is 2 plus 1, which is 3. Okay, so it would be something like this. Okay, so the 3 I would be putting at the denominator here lah. So here would be 2 times 3. And for the 1 here, because it's just a value, so if we integrate, I just put an x with it. So here would be plus x. Alright, and don't forget to put the limits at the end of the bracket here. And for this one, we can just put into the calculator to find out the value. Right, so now for this one, we are just going to substitute the 2 values inside here, and we are going to find out its difference. Right, so this is the result when we substitute 2. Right, so here it becomes 6 because 2 times 3, so it's 6 here. And we're going to minus with the result when we substitute 0. Okay, so this entire thing is actually 0 now. Right, because all of these things have x, and if all the x change to 0, it will be 0. Right, and don't forget the negative 9 over 4 here. So once we put this into calculator, and you can find out the final answer, which is 13 over 12 units square. So before we go to the next question, I just want to let you know this thing, which is very important when we are using integration to find out the area. Alright, so when we use this one, alright, and if we have areas above the x-axis, their values will be positive. But if we have areas under the x-axis, it would be a negative value. So the questions that we need to be careful would be something like this. Alright, something like this. There are areas above the x-axis, which is region A, and areas which are below the x-axis, which is region B. So let's say the question tells us to find the total area of A and B. How are we going to do it? Right? And let's say here the value is 1 and here is 2. Right, so how are we going to do it? So first thing first, we need to calculate them separately. Right? Which means area A, it would be from where to where? And area B, from where to where? Okay, we need to separate 2 integrals. So for this one, if you want to find out area A, it would be from 0 to 1, right? 0 to 1. And for B, it will be from 1 to 2. Okay, so we separate. Do not calculate the area from 0 until 2. Okay, why we cannot do this is because for the integral, right, when we integrate from 0 to 1, you will see that it is a positive value, right? The areas which are above the x-axis, the values would be positive. But if we have areas which are below the x-axis, their values are negative. So if we just integrate from 0 straight to 2, it is like adding up positive areas and negative areas, meaning we are finding the difference between A and B, which is not what we want, right? What we want is the sum. The sum of these 2 areas, the total areas. So we need to add them up together. So how are we going to add them up together if one is plus and one is minus? One is positive and one is negative. So this is the second thing we need to do. We need to apply modulus to the areas which are negative. Okay, so means for this area B here, I will need to apply modulus. So this value here, it will become positive once we apply the modulus. Okay, so for the total area here, it would be area A plus the modulus of area B. Okay, so there are two things we need to do. First thing first is to calculate them separately. The regions which are above the x-axis and the regions which are below the x-axis, we need to calculate them separately, which means we have a A and the B here. And for the regions that has a negative value, we need to apply the modulus, which what we have seen in area B. Okay, so these are the two things that we need to take note. So this also applies for y-axis also, right? So if we have regions which are on the right side of the y-axis, their values will be positive. But if we have regions which are on the left side of the y-axis, it would be negative, right? Having negative values. Okay, so using the same way, calculate it separately and apply modulus to these regions which are on the left side of the y-axis. For question 10, it goes back into progressions, and for this time in part A, it focuses on arithmetic progression, and in this question they are asking us whether this sequence is an arithmetic progression or not, and we need to prove it. Alright, so let us recall back what is arithmetic progression. Alright, so it's a sequence of numbers where if you want to find the next number, it's either we add or we minus a value, and usually that value is D, which is also called the common difference. So let me give you an example of arithmetic progression. So let's say this sequence starts with 2. So let's say the value I want to add is 2, so the next number would be 4. And if I add the same value, it would be 6. Add the same value would be 8, and so on. Okay? And since these values are using the same value, these values are also called the D. Okay, the common difference. Why it's called common is because all of the values here are using the common value, the same value, which is why D is called the common difference. Right? So going back to the question here, how can we prove whether this is an arithmetic progression or not? So here, because just now we have mentioned that all these values must be the same, and all these values are the D. So why not here we also try to check what is the value being added here, and we see whether it is the same or not. If it's the same, means it is an arithmetic progression. If it's not the same, then means it is not a progression at all. Right? So means here we need to find out the value of D for each of the values here. Okay, so we need to figure out the 3 values of D here. So let me tidy up this thing a bit. Alright, so means we need to figure out what is D1, D2, and D3. Okay, so how do we find D1, D2, and D3? Actually quite simple. So let's say if you want to find out D1 and we focus on these 2 values, so basically the value in front minus with the value at the back. Right? So it will be just 4 over 3m minus m over 3, which is m. Alright, so let's do the same thing when we are finding D2. Okay, so D2 would be these 2 values. So the value in front minus the value at the back. So D2 would be 7 over 3m minus off with 4 over 3m, which is also m. Okay, so now let's go to the third D. So third D is here. Okay, so again the same thing, the front value minus the back value. So it's still m. Okay, so all of the d values here are actually m, which means this is an arithmetic progression. Okay, so here we just need to write a short conclusion. So since d1, d2, d3 is the same, the sequence is an arithmetic progression. For part B, we need to prove another formula, but this time it is focusing on arithmetic progression. Alright, so this is progression, and we need to show the sum of the first n terms formula, right, which is the Sn, which is also one of the formulas in the formula sheet, right, formula 10. So we need to prove this formula. Okay, so to prove this formula, let us understand Sn first. Okay, Sn is sum of the first n terms, so means we need to find out the sum of t1 plus t2 plus t3 until the last term, which is n, right? If there is first n terms, the last term will be nth term. So for example, if let's say it's S4, so it would be t1 plus t2 plus t3 plus t4. Okay, the value here and here is the same. The value of n and n here is the same. Okay, so let's write out this thing. So Sn is equal to t1 plus t2 plus t3 until it is tn. Okay, so here just a note, because I want to show y'all the expression when it's these two values, so I write out these two values. Okay, and here is n minus 1 because it's the value before n, and this is n minus 2 because it's the value before n minus 1. Okay, so now for each of the terms here, let us use the formula here, right? Formula 9, right? Let's write out the expression according to the formula here. So for the first one, this is t1. T1 is actually the first term, and we know the first term is a, so this would be just a. Okay, and for each of the terms here, I put a square bracket here is because I want y'all to differentiate what is what. Okay, which term is for which expression, so it makes the entire working here more clearer lah. Okay, so now for t2, so our value of n now is 2, so means the n here will change to 2, which means here would be a plus 2 minus 1d. So 2 minus 1 is 1, so it's d only. So here it's a plus d. Okay, and when n equals to 3, so 3 would be something like this. So it would be a plus 3 minus 1d. So 3 minus 1 is 2, so a plus 2d. Okay, and we are using the same technique for the other three terms here. Okay, so let me explain how does these expressions come out. Alright, so let us change the value of n here. So let's say now it's n minus 2. Okay, n minus 2. So n here will change to n minus 2. So this thing will become n minus 2. So here will be a plus n minus 2 minus 1d. Right? So it's also here. A plus n minus 2 minus 1d. Okay? And now we go to n minus 1. So this one will change to 1. So this would be a plus n minus 1 minus 1d. Here will be a plus n minus 1 minus 1d. Okay? And the last one is tn. So basically it's the formula. Right? tn equals to a plus n minus 1d, which is here. Alright, so this would be our first expression of Sn. So now let's form another expression of Sn, but this time we don't need to do so many workings like in the first expression. Right? We don't need to this t1, t2, t3, blah blah blah, and to find the expression. We don't need to do that. What we need to do is quite simple, is to flip the entire expression for the first Sn. Okay, so means for the last value of the first expression, we are going to put it into the first value of the expression. Okay, and then the last second value here, it will be the second value. Last third value will be the third value, and so on. Okay, so the first three values in the first expression will now move to the back already. So the last value here is A. Alright, so now with the two expressions here, what we are going to do is, for left side and right side here, we are going to add them up together. The first expression and the second expression, we add them up together, right? So basically, Sn plus Sn here would be 2Sn. Okay, and for each of the values here, how are we going to add them up? So basically, it's like this. The first value of the first expression, which is A, I'm going to add with the first value in the second expression. Okay, so means the second value with the second value, third value with the third value. The last third value would be adding up with the last third value, and so on. Okay, so let's try this out. So A plus n minus 1d. So here would be 2A, right? A plus A would be 2A, and the things at the back remains the same. Okay, for this one, same thing also, there is 2A's here, so it will be 2A. And here it's n minus 1 minus 1d, but there's a d here. So meaning we are going to add 1 with the d. So the minus 1 and the plus 1 I can cancel off. So it's n minus 1d. Okay, and the third one as well. So A plus A is 2A. And if you see the d's, there's a 2 here, and there's n minus 2 minus 1 here. So if I add 2, means minus 2 and plus 2 I can cross off. So it's n minus 1d. Okay, and it will be the same for the rest of the values at the back. And if you look closely, actually all of the values, once we sum up, is the same. Do you realize that? All of the values here are the same. Okay, so this is the technique of this proving method. So we add up all the values to make sure that all of the values here becomes the same. And what we do is we just sum them up together. We just need to figure out how many values of this thing it has here. Okay, so let's go back to our first row. Yeah? First row, how many terms do we have here? N terms, right? Because it's the sum of the first n terms. So means we have n times of these values. Okay, so to sum it up, we just multiply n in front and we put the value at the back. Because here, again, we have n values of the 2a plus n minus 1d here. Right, we have total n values of this thing. Okay, so if you want to summarize, it will be just n multiplied with the value. Okay, so now we need to figure out Sn, right? So the 2, I'm going to move it to the right side. Alright, so as you can see, we have proven the formula. Okay, so what we need to do here is Sn. Let's list down all of the terms, and we use the formula to list out all the expressions. So we form the first expression, and then the second expression here, we flip the entire thing. Okay, and then we add both of the expressions together, and you will notice the values on the right side, all of them are the same. Then we summarize them together. So it would be n with the value here, and then we move 2 to the other side, then we can get the formula already. For part C, we are given the sum of the first n terms of this arithmetic progression, which is this value, and we need to figure out the nth term, which is Tn. So from Sn here, how do we get Tn? Okay, so let us compare the expression of Sn with the formula given here. So if we compare, actually we cannot compare because the denominator here is different. One is 12 and one is 2. And the other thing is the things inside the bracket. The things given here in the bracket is actually quite simplified. And if you want to split it out, for example, something like this, it's very hard. Okay, so we are unable to compare these two formulas, and we are unable to find out the value of A and D. Okay, so we cannot use this formula. So since we cannot find the value of A and D, so the formula 9, which is Tn formula, we also cannot use. Alright, so now it's just purely on here, Sn and Tn. How are we going to find it? Right, so let us find out the relationship between Tn and Sn first. Okay, so let me give you a simple example. Right, so let's say we have three terms here, T1, T2, and T3. So now we need to find out T3. Okay, and to find out T3, we cannot use the formula here. We can only use Sn, or meaning sum. So how are we going to use sum to find terms? Okay, so there's actually a way. So the way is, let us find out the sum of all of these three terms first, which is S3. Okay, and since I want to find the third term only, so means I need to remove T1 and T2, right? And actually we can find the sum of T1 and T2 because this is the sum of the first two terms, which is S2. So means to find out T3, it would be S3 minus off with the sum of the terms that I don't want, which is S2. Okay, so T3 equals to S3 minus S2. Right, T3 equals to S3 minus S2. So if we want to change this into Tn and Sn, so means the values here, we change it to n, so it would be something like this. Oops, sorry. So if you compare here, the 3 here is actually n, right? So for the 3 here, it will also be n, and since this is 2, which is one value lesser than 3, so here will be n minus 1. Okay, because 3i minus 1 is 2. Okay, so this is the relationship between Tn and Sn. Okay, so now if we want to find out Tn, we are just going to use this expression. Alright, so the Sn, which is this value here, alright, and minus off with the sum of the first n minus 1 terms, which means all the values of n here, right, this value and this value, I need to change it to n minus 1. Okay, so now let us simplify this entire value here. Okay, so for the n, I'm going to multiply inside the bracket here, so it will be 4n squared plus 5n. For this part, I'm going to simplify the things inside first, so here will be 4n plus 1. Okay, and then we are going to cross multiply the values. So n times 4n, n times 1, negative 1 multiply 4n, negative 1 multiply with 1. Okay, so this would be the expression. Okay, so the result, let me put it here, which is, so you cross multiply, you will get this one, but since there is a negative here, so positive will become negative, negative will become positive, right? So these two values will become negative, these two values will become positive. Okay, and then I simplify this entire thing, so here there's a 4n squared and a negative 4n squared here, so these two can cross off because once we add them up, it will be 0. And for the 5n here, minus n plus 4n, so it's 8n, and the 1 here, it will remain, and the 12 here will remain also. So this would be our expression of Tn. Next question, going into permutations and combinations, and in part A, it says we have a group here and it has 3 adults and 5 teenagers, and they are seated at a round table. Okay, a round table. So now we need to find the number of ways if they can be seated using these two criteria. Right? So for any other permutation or combination question, we need to ask ourselves this main question, which is this question a permutation question or a combination question? Alright, so I give you all 5 seconds to think about the answer. And the answer is permutation, right? Because here we have the 3 adults and the 5 teenagers. We need to arrange them in this round table, right? So let's say we have this round table here and there are 8 seats in total. So we can arrange the 3 adults and the 5 teenagers in these seats. Okay, so we are looking at their seating arrangement. So we are going to use permutation. So I know that there is no keywords in this question like arrange or select, but sometimes we need to look at the situation here. If we are in the situation, what would we be doing? Would we be arranging them or not arranging them? Okay, so for the first part, it says there are no restrictions. So the adults and the teenagers, they can sit freely. Right? So if they sit freely, what would be the number of ways? Okay, so since this is a permutation question, let's pull down the list of formulas for permutation. Okay, so now we are arranging all of the people here, right? The 3 adults and the 5 teenagers. So we are going to look at this row and we are arranging them in a round table, meaning a circular table, meaning a circular arrangement. So we are going to look at this column, right? This column here. So the formula we should be using is this one, n minus 1 factorial. Okay, so the value of n here is the number of people that we need to arrange. So we have in total 8 people, so it would be 8 minus 1 factorial, which would be 5040. And for part 2, the condition is 3 adults are not seated together. Alright, not seated together. So if we compare not seated together with seated together, if we want to find the number of ways, seated together will be easier. Alright, because we have a technique to find out the number of ways when they are seated together. Okay, so here, if we want to find out the ways of not seated together, what we can do is, why not we try to find all of the ways that we can arrange these 8 people? And then since seated together is much more easier to find the number of ways, so why not we use all the ways minus out the ways they are seated together. So if we minus out these 2, then we can find out the number of ways they are not seated together. Okay, so let's try out this way. So all the ways, the number of ways to arrange all of them, actually we already found out in part A1, which is 5040. Okay, so now we need to figure out the number of ways seated together. Okay, so here in this diagram, let me change the color a bit. Right, so let's say the teenagers have already seated here. Alright, and the adults, because they are seated together, so they'll be taking these 3 seats. Okay, so now in this situation, what is the number of ways if the adults are seated together? Alright, so the technique is, if we want to find number of ways they are seated together, the people that are seated together, we need to group them into one person. Right, so meaning, for these 3 adults here, I am going to group them and we imagine them they are just one person. Okay, just one person. From 3 adults combined into one person. So now, if we want to arrange the number of people here, it would be 1, 2, 3, 4, 5, 6. Right? Because this thing has been combined into one person. So we need to arrange 6 person here. right? So coming back here in this formula, so since we are arranging 6 people and it's in a circular arrangement because it's a round table, so we'll be using back the same formula. So the n here will be the number of people we are arranging, which is 6. So here would be 6 minus 1 factorial. Okay, so now we have arranged all the people here. So now let's arrange the people in the group. Right, the 3 adults here in the group, because the adults in the group, they can change their places within the group itself. So for example, this person wants to change place and sits here, and this person wants to change place and sits here, and this person wants to change place and sits here. Okay, so you can see that these adults are changing their places within the group itself. Right, so here we need to find the number of ways to arrange these 3 adults, which will be 3 factorial. Right, because we are arranging 3 persons within the group. Alright, so it's multiply 3 factorial. And with that, we have found the number of ways they are seated together, which is 720. Alright, so now we have found out the number of ways to arrange all of these people and the number of ways seated together. So now we can minus them together. Right, so 5040, the answer in part A1, minus out the answer we have gotten just now, 720. So our answer would be 4320. But before we go to the next part, I just want to explain this one, the 3 factorial here. So some students may be asking, isn't this actually a round table arrangement? So shouldn't we be using the circular arrangement formulas, which is n minus 1 factorial? So means for this one, it's 3 minus 1 factorial. Okay, if you look closely on how they change their places, it's just within the group, right? Within the group. But when they are arranging themselves, they are not arranging in a round table. Right? Meaning, inside the group itself, there is no round table. Right? It's just changing their places here and there. So this is actually a straight line arrangement. Right? Because again, in the group itself, there is no round table inside the group itself, right? So this is a straight line arrangement. That's why we used this formula, n factorial. Okay, so since we have 3 people here, so it's 3 factorial, not 3 minus 1 factorial. For part B, we are looking at an entrance assessment paper, right? And it says there are 6 questions in section A, 7 questions in section B. So for each candidate, they must answer 10 questions. Okay, so this is questions with the condition at least they must answer 4 questions in section A, and okay, so here it's not more than, right? So answer not more than 5 questions from section B. So now we need to find out the number of ways for the candidate to answer 10 questions in the examination. Okay, so again, for any other permutation or combination question, we need to ask ourselves, is this a permutation question or a combination question? Right? So I give you 5 seconds to think about this. And the answer is combination, right? Because here we are just trying to select the questions from section A and B and to solve them. We are not arranging the questions in section A and section B. Okay, so for example, in section A, from 6 questions, we need to select at least 4 of them. Right? So this is a combination question, not a permutation question, because there is no arrangement involved here. Okay, so now we need to find the number of ways according to these 2 conditions, right? At least 4 questions in section A and not more than 5 questions in section B. Okay, so you can imagine there are a lot of possibilities, right? So if there are questions that have a lot of possibilities, what we can do is use this technique, which is to draw table. Okay, so let us draw this kind of table. So for the columns here, what I'm going to put usually is the number of groups that we have, right? So for this round, for this question is the number of group of questions. Okay, because here we have 2 groups of questions. One is coming from section A and the other is coming from section B, right? So there are 2 groups of questions coming from 2 sections, section A and section B. Okay, so in this table on the top left here, I'm going to put the number of questions in section A, which is 6. And here I'm going to do the same thing also. So the total number of questions in section B, which is 7. And then on the left side of this table, I'm going to put the total number of questions that you need to answer, which is 10. But this time, these group of questions here, section A and section B, have their own conditions, right? So let's put the conditions on top of the column here. Alright, so for section A, the condition is at least 4 questions from section A, right? So we're gonna put at least 4 questions here. And for section B, it's not more than 5 questions, meaning we cannot exceed 5. It can be 5, but we cannot exceed it. For example, 6, 7, 8, and so on. Alright, so now in this part of the table here, we are going to list all of the possibilities. Okay, so since section A here, the condition is at least 4, so let's start with 4. We are going to answer 4 questions in section A. So this means we need to answer 6 questions in section B, right? Because in total, we need to answer 10. So 10 minus 4, 6. Right? But does this 6 satisfy the condition here? The answer is no, right? Because we already exceed 5. Okay, so this cannot be our possibility. So why not here we add another question in section A? So from 4 we go to 5. Alright, so if we answer 5 questions in section A, so we need to answer 5 questions in section B, because in total we need to answer 10 questions. 10 minus 5, 5. And we see the 5 here actually it satisfies the criteria here because we didn't exceed 5. It is 5. So this can be our first possibility. And let's go to the next one, right? So let us add another question in section A. So it's 6. So means we need to answer 4 questions in section B. Again, we are answering in total 10 questions. Alright, so if we see this value here, it is lesser than 5. Okay, so this can be also our possibility. Alright, so let's go beyond 6. Let's add another question in section A. 7. So means in section B, we need to answer 3 questions. Okay, so 3 is also lesser than 5, so this can be our possibility also. But is that the case? We need to look at the total number of questions in section A. Here we only have 6 questions. So means it is impossible that we can select 7 questions in section A. Okay, so this one we need to remove already. So in total, we have 2 possibilities for our situation here. So now we have already found out all the possibilities from our situation here. So let's find the number of ways. Okay, so here from the first possibility here, from 6 questions, I choose 5 of them. So it's 6C5. And here from 7 questions in section B, I choose 5 of them, so it's multiply 7C5. Okay, so this is for the first possibility, and now for the second possibility, we are going to add, right? We're going to add 6, we choose 6 questions, so 6C6, and we're going to multiply with 7 questions, we choose 4 of them, so it's multiply 7C4. Okay, so once we have this, we can put into the calculator and find out the answer, which is 161. And the last question in section A, so I'm not going to reveal is from which chapter first, so let's go through the question and let's see it's from which chapter. Okay, so here we have a survey and it's found out that 1 out of 3 students uses mobile phones, right? Uses mobile phones, and if 8 students are chosen, in part A, we need to state all the possible outcomes. Alright, so in this question itself, I think it's still not very obvious it's from which chapter. So let's go to part B. Right, part B, it says calculate the probability. Alright, so since we are calculating the probability, then it would be from the probability distribution chapter, right? From chapter 5 chapter. Right, so in this chapter, we have learned 2 distributions. One is binomial distribution and one is normal distribution. Right, so if we are calculating the probability, which distribution are we using? Are we using binomial or are we using normal? Right, so I let you all to have 5 seconds to think about this. So the answer depends the number of outcomes in this survey, right? So it says here the students have mobile phones, right? So this is one of the outcomes. The student has mobile phone. How about the other students? The other students would be do not have mobile phones, right? The other students do not have mobile phones. So this is the other outcome. So in total here, there are only 2 outcomes. And which distribution calculates the probability in situations that has 2 outcomes only? The binomial distribution, right? Because binomial distribution helps us to calculate the probability in situations that has 2 outcomes only. Okay, so this is a binomial distribution question. Okay, but before we go to part A to solve the question, we need to ask ourselves this thing. Because binomial, there are 2 outcomes, so which outcome are we following to answer the questions? Are we following mobile phones or do not have mobile phones? So meaning which perspective are we following? Mobile phones or do not have mobile phones? Alright, so we can look at a few things. So for example, the result of the survey here, it says 1 out of 3 students have mobile phones. Okay, so we can use the mobile phone perspective to answer the question. And also in part B, you will see that we need to calculate the probability that more than 2 students have mobile phones, right? Have mobile phones. So again, another indicator that we can use the mobile phone perspective, the mobile phone way. Okay, so in this question, let us use the mobile phone perspective. Alright, so now going into part A, we need to state all the possible outcomes. Right, so let's set what is our value of x. Right, so what is our value of x? So now, since we are looking at the mobile phone perspective, so we are looking at the number of students that has mobile phones. Right, so what would be all the outcomes of x here? Okay, so let's think of the 2 extreme cases. So from the 8 students that we have chosen, let's say the first extreme is none of them have mobile phones. So x can be 0, right? x can be 0. And let's think of the other extreme. From 8 students, all of them have mobile phones, right? So it's 8. So if we want to state all the possible outcomes would be the values from 0 until 8, right? From 0 until 8. So all of the values inside of it will be the possible outcomes. Alright, so make sure in the answer that you have put this set bracket, right? Because we are looking at a set of numbers for our possible outcomes. So since this is a set of numbers, we need to put the set bracket. For part B, we need to find out the probability that 2 or more students have mobile phones, right? So means we need to find out the probability where x, we can use x here is because we are looking at the number of students with mobile phones, right? With mobile phones, right? Where the x value is more than 2. Right? So to find out the probability, let's see which of the outcomes here are greater than 2. Right? So if we look at the answer in part A, these values are greater than 2, right? Starting from 3, 4, 5, 6, 7, 8. So these are the outcomes which are greater than 2, which means for each of the outcomes here, we need to calculate its probability. So in total, there are 6 probabilities that we need to calculate. But 6 probabilities is a bit too much, right? There's a lot. So we can use the shortcut way. Right, so what is the shortcut way? So shortcut way is, let us consider the total probability of all the outcomes here, which we know it's 1, right? The total probability of all the outcomes. And instead of calculating the probability for all these 6 outcomes, why not we minus with the probability of outcomes that we do not want, which is the 0, 1, and 2, right? So with the total probability, we minus off the probability of the outcomes that we do not want, which is the 0, 1, and 2. Okay, so to calculate the probability when x is greater than 2 would be 1 minus off the probability where x equals to 0, x equals to 1, and x equals to 2. Okay, so here, using this way, we only need to find out 3 probabilities of these 3 outcomes. Instead of just now, we need to calculate 6 probabilities, which is too much already. Okay, so this is the shortcut way. Using the total probability minus off the probability of outcomes that we do not want. Alright, so now how do we find out the probability when x equals to 0, x equals to 1, and x equals to 2? Well, we can use this formula, right? Formula 23 in the formula sheet. So to use this formula, we need to understand what is n and what is p first, right? So n here is actually the number of trials. The number of trials meaning how many times did we repeat the experiment. So here, the number of trials is actually 8, right? The n here is 8. But you may be asking, did we repeat the experiment 8 times? Yes, actually we did, because, right, let's say from the bunch of students here, we select the first student in our experiment, right? So this would be our first experiment or our first trial. Then we ask this first student, do you have a mobile phone or do you not have a mobile phone? Right? So this is for the first student. So once the first student is done, then we take out another student. So this second student would be our second trial or our second experiment. So we also ask the same question. Do you have mobile phone or do not have mobile phone? Right? So once the second student is done, then we will select the third student and so on. And this experiment will repeat until they have chosen 8 students. So if there are 8 students, means there are 8 experiments, 8 trials, which is why n here is equals to 8. Alright? And for p here, p is actually the probability of success. Right? Probability of success. But how do we define success? Well, actually it depends on our perspective just now. Because now our perspective is students with mobile phones. So we need to find out the probability that the student have mobile phones, which is given here. 1 out of 3 students have mobile phones. So this means the probability is 1 over 3. Okay, our p is 1 over 3. Okay, so now we have the value of n and the value of p, then we can use this formula to find out the probabilities where x equals to 0, 1 and 2. Okay, so let's start off with probability where x is equal to 0. So we're going to start off with the value of n here, so it's 8, and CR, R is the value of x here, which is 0, and we're going to multiply with the probability of success, which is 1 over 3, and we're going to put the R here, R is 0, and Q. Okay, Q here is the probability of failure, which is the opposite of probability of success. So if you want to find Q, very simple, it's just 1 minus the probability of success, right? 1 minus 1 over 3. And the power here is n minus r, so it's 8 minus 0. And to find the probability where x equals to 1 and x equals to 2, we can use back this thing. So the values in red and blue will be the same, it's just the values in green will change. Alright, so for example, if probability where x equals to 1, all the green values here will change to 1. The rest of the things remain the same. So same goes when probability where x equals to 2. The values in green all change to 2. Okay, so if you put this into your calculator, and please make sure you typed it correctly, alright, the probability that you will get is 0.5318. Alright, moving on to section B, and the first question comes from functions, and in part A we are given the relation diagram that maps set x, which is a set on the left side, to the right side, which is set y. Okay, so the things inside set x are also called the objects, and the things which are in set y are called the images. Okay, so this means that if these objects are put into the arrows here, or the arrows are usually representing the function f of x, so it will produce the images. So the objects here, A, B, C, put inside f of x, it will produce the images 1, 3, 5. Okay, so now the question asks us whether this relation here is a function or not, meaning whether this f of x is valid or not. Right, so to answer this question, let us apply this into a real life scenario, right? So let's say the objects here are the coffee beans. Alright, and the images here, it would be the coffee. And the f of x here would be the coffee maker. So means, if I have coffee beans, I put into the coffee maker, then I can produce coffee. Right? Because it's the same thing where we put the objects inside f of x, it will produce the images. Okay, so now with the coffee beans, coffee maker and coffee, let us see whether it is logical or not. And let's give our justification, our explanation. Why is it a function or why is it not a function? Alright, so let's focus on the things in set x. Okay, and let's look at this object here, which is B. Right? As you see, it doesn't attach to anything on the right side. Okay, so for this B here, let us apply it into the coffee bean scenario. And let's see whether it's logical or not. So now we have coffee bean B. We put into the coffee maker, but because it does not attach to anything here, means there is no coffee produced. It's a bit weird, right? Because coffee beans, if I put coffee maker, should have a coffee, but now it's not. I put coffee beans into the coffee maker and there's no coffee. So means there is something wrong with the coffee maker already, which means the f of x here is not working. Alright, so in the ideal scenario, each of the things in set X, meaning for every object here, it must have an image. Okay, so this is an indicator that this thing is not a function. Right, so we can write it here because not all the objects here have an image, which is object B. Right, so this is the first reason. And the second reason is we can look at object A. As you see, object A is attached to two images. So does it make sense for function? Okay, so let's put this object A into the coffee bean scenario, right? So coffee bean A, I put into the maker here. It will produce two types of coffee because it's attached to two values here. So two types of coffee. So does it make sense or not? One type of coffee bean put into the maker and produce two types of coffee beans. It's impossible, right? Because one type of coffee bean should produce one type of coffee only. Okay, so again, this f of x does not make sense for this situation also. Okay, so in function terms, this is actually called the one-to-many relation, right? One value to many values here. Okay, so functions cannot have one-to-many relations. So this is another reason why it is not a function. Okay, so functions, they will only have two relations. So the first one is one-to-one, and the other one is many-to-one. Okay, if we have these two relations, then it is a function. So for example, one-to-one is here, right? Object C will produce image 5. So this one makes sense. Many-to-one also makes sense because, okay, let's say we have this relation. A to B will go to 2. So let's say if we put these two things into the coffee bean scenario, right? Okay, let's say there is 50% of coffee bean A and 50% of coffee bean B. So if I mix them together in this coffee maker, it will produce one type of coffee. Makes sense, right? Because we are just mixing up the coffee beans only. Right? So for functions, we'll only have two relations, one-to-one and many-to-one. Okay, so our conclusion here is it is not a function because not all objects have an image, which is the object B here, and it is an one-to-many relation because here is the object A. It has one-to-many values. And for part B, we are given this function f of x, and we need to express x in terms of b using this equation. Right, so express x in terms of b, meaning we need to form an equation where x is on the left side, whereas the other things are on the right side. So one of the things is b. Okay, so now to find out this equation, we first need to find out the values of these two functions. Right, but what is the 2 here? What does f2x mean? Right, so this 2 means double, and double is actually there are two functions of f inside this function. So meaning it is fx. So this square is just a shortcut to write that there is two functions of f inside a function. Okay, it's just a shortcut only. Alright, so now let us find the value of f of x and f double x here. Okay, so f of x, we already found it, which is 4x plus b. Okay, and now let's find the value of double fx. Okay, so inside of it there is 2f, but like any other composite function, so composite functions are functions that have two or more functions, right? We need to focus on the things on the inside first, which is the inside f. Okay, so the inside here is f of x, so we have the f of x already, so we can just change it to 4x plus b. So now, how do we put this 4x plus b into the function to find out the expression? Okay, you can imagine that the things inside the bracket here, it's the new value of x, right? New value of x, which means if I go back to the function f here, so the things inside the bracket, originally it was x, so now I change it to 4x plus b. So means the things on the right side, all the x, I also need to change to 4x plus b. Okay, so using the function f, which is 4x plus b, the x value here, now I will change it to 4x plus b. Okay, so this is the expression of double fx. So what I need to do to simplify this expression is to multiply 4 into the bracket here. So 4 times 4 here will be 16x, and this b would be 4b, and this 4b will plus with b on the outside. So here will be 16x plus 5b. Okay, so now we have the expressions for both double fx and fx. So let us put the values into this equation here. So f double x would be this value, and f of x would be 4x plus b. Okay, so now going back to the condition of the question here, x must be on the left side of the equation. So what we are going to do is to move the things which has x to the left side. For example, this 4x need to move to the left side. So this 5b, since it does not have x, I'm going to move it to the right side. Okay, so here 4x, if I move to the left side, it will minus with 16x already. So here will be 12x. And this 5b, I move it to the right side, it will be negative also. So we'll minus with b here to get negative 4b. And now for the 12, I'll move it to the other side and simplify with 4. So here will be x equals to negative 1 over 3b. And this would be our expression. For part C, we have a new function, which is function g, and it is x over 3. So now in part 1, we need to state the function of inverse of g. Alright, so how are we going to inverse this function here? Right, so I know that the steps to inverse a function is quite complex and not easy to memorize. So here I try my best to explain it in great detail and also to help memorize the steps even easier. Right, so what I'll be doing is, for this inversing a function thing, I'm going to apply it into an action that we do all the time, which is washing clothes. Alright, so let's say we have a shirt here, and outside and inside of it is dirty. Okay, outside and inside of this shirt is dirty. So what we are going to do to clean this shirt, of course, is to have soaps, right? So here, let's prepare two soaps. So for the first soap, we are going to clean the outside, and this soap, we are going to clean the inside. So that's why there are two soaps here. Okay, but you may be asking, this shirt and the soap, how are we going to apply it into our function here? Okay, so you can imagine that this function here is the dirty shirt. Alright, and these two soaps would be these two equations. Okay, so how did these two equations come out? Right, so here we are given g of x, right? So let us assume that it is y. Okay, so this is for the first equation. And for the second equation, do we need to memorize this? Actually, we don't need to. Okay, because it is from the first equation, right? So you can memorize it in this way. So this g, if you move it to the other side, So it's G inverse of Y, right? And the right side of it is just X. Because G, we already move it to the left side, right? So if you compare this equation with this equation, it's actually the same, right? X equals to G inverse of Y. G inverse of Y. Okay, so this would be our second equation, and we don't need to memorize because it is from the first equation. Okay, first equation. Right, so now we have the surds and the slopes and the equations ready. So how are we going to clean this surd? Right, so we are going to follow these 4 steps. Right, so the first step of course is to apply the slope into the outside of the surd to clean it. Right, so once outside of the surd is clean already, then we go to the second step, is to flip the surd inside out, right, to access the things in the inside of the surd. Right, so once we have the access of the inside of the surd, then we can apply the second slope to clean the inside of the surd. Okay, so now outside and inside of the surd is clean already, then we can go to the last step, which is to flip back the surd. Right, so now for these 4 steps, how are we going to apply it into our function here? Right, so the first step is to apply the slope, right? So we are going to apply our first equation into our function here. So here it says y equals to g of x, so this g of x, I apply it and change it to y. Alright, and the second step is to flip the surd, right? So what are we flipping here? So we are going to flip the left side of the equation here from y to x. So meaning x is on the left side, everything else move to the right side. So here will be x equals to 3y. Then the third step is to apply the second slope, right? So here we are going to apply our second equation, x equals to g inverse of y. So since we have x here, so we need to change it to g inverse of y. We apply it to change it to g inverse of y. Okay, and the last step is to flip back the surd, right? So just now we flip from y to x, now we do the same thing, from y to x. Okay, so since we applied these 4 steps and we have found out the inverse of g, which is 3x. And for part 2, it says we need to show this result. Alright, so there's a lot of things going on here, so let's go through one by one. Right, so on the left side here, inside the bracket here, there's a double g. Okay, so means we need to figure out the expression of double g first. Right, we are going to find the double g first, and then since there's an inverse outside, means once we have the double g, we are going to inverse it. So means double and then inverse. For the right side here, inside the bracket there is the inverse of g, right? So here we first need to figure out the inverse of g. So we need to inverse it first. And then since there is a double outside, so means once we have the g inverse, we need to double it. So means we need to have double of the g inverse. Okay, so for the left side is we double the g and then we inverse. Right side of it is we inverse the g first, then only double it. Okay, so it's the other way around. Okay, so we need to find out the expressions of these two things and we need to ensure that they are the same. Alright, so let's find out the expression of this thing. So we are going to double it and then we are going to inverse it. Right, so let's find out the expression of double g. Right, so ggx. So similar to any other composite function, we are going to focus on the function which is inside first, right, which is g of x, which is also given in the question here, right, x over 3. Okay, so we can change it to x over 3. So now how are we going to use this value and apply it into G? Okay, so similar to part B, you can imagine that this value here is the new value of x. Okay, so if we go back to the function G here, we assume that this value of x now has changed to x over 3, which means all of the x here will change to x over 3. Right? So once we put this x over 3 inside G, we will have this result, x over 3 over 3. Okay, so let us simplify this thing. So over 3 here means we divide with this function here, sorry, this fraction here. So it will be x over 9. Okay, so we have found out the expression once we double it. Okay, so this one is done already. So now let's inverse it. Okay, so how do we inverse this thing? Alright, so let's look at the function G. Okay, sorry, let me erase this a bit. If you look at the function G, right, the value is x over 3. Right, x over 3 is actually quite similar to our double G here. Both of them are fractions, both of them have x on top, it's just that the value at the bottom is different. Okay, so this means we can copy the result once we inverse the G here, which we already found in part 1, right, which is 3x. So means the x I'm going to put it here, and 3 I'm going to put it here. So again, because it has the same structure where both of them are fractions and the value on top is x. Okay, so we are going to do the same thing. We are going to put x here and the value at the bottom here. Alright, so by using the same pattern, we have found out the double G inverse of x, right, which is 9x. Okay, so we have also inversed this function. Alright, so now we have found out the expression is 9x. So let us see whether when we inverse the G and we double it, whether it is 9x or not. So for this one, we are going to inverse it first, but we already inverse it, right? Because in part 1, we already found the inverse of G. So we have already done this one. Okay, so now we need to double it. Right? So let us find the expression when we double the inverse of G. Right? Double the inverse of G. So we have found out that the inverse of G is 3x. Right? So now if we want to put this value inside the inverse of G, how are we going to do it? Well, we can assume that this is the new value of x. So meaning here, the value of x here will change to 3x, which means all of the x values will change to 3x. So this means it would be 3 and inside of it is 3x. Okay, so once we multiply 3 inside here, we will also get 9x. Alright, so we have double the inverse of G already, and as you can see, these two results are the same. So we have shown this equation already. Right, so we can write a small conclusion here. We can say hence the double G once we inverse is equal to the double of inverse G. Question 14 focuses on the indices, surds, and the logarithms chapter, and in part A, we need to solve these indices questions. Alright, so in part 1, we need to simplify this expression here. Right, so the key to solve any indices questions is we need to make sure the base value is correct. So what do I mean by base value? It's actually this value, the value a here. Right, so we know that n is the power, so a here is actually the base. So we need to make sure the base values inside this expression is the same. But if you see here, all of them are different. Alright, so what we need to do is to change them into the same base value. Right, but you will be asking, which value should I change to? So what I would recommend is change to the smallest base value among here, which is 2. Alright, 2. So let us change all the bases here to be 2. Okay, so let's start off with 4. So for 4, how are we going to change it to the 2 power of something? Okay, this we already know because 4 is 2 square. Right? So if we change 4 to 2 square here, we have changed the base from 4 to 2. Okay, similar to the one here. So let's go to the second value, 25. So let's see, 25, how are we going to change it to 2 to the power of something? Alright, this one would be a bit hard because if we see 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. So you can see the value already skipped 25. Which means it is not possible to change this 25 to 2. So what are we going to do here is, let us change another base value for 25. So since 2 we cannot use already, and 4 already changed to 2, so the other value left is 5. Right? So let us change it to either one of these two values. Either it's 2 or 5. Okay, so for the 25, if we want to change it to 5 to the power of something, actually we can, right? Because 25 is 5 square. Right? So for this 25, we have changed it to 5 square, similar to the value here. Okay, so now the base values here we don't need to change because we want to change to 2 and 5, right? So we don't need to do anything. We just adjust the value of 4 and 25 here. Okay, so let's write this into our working here. So the bottom, we are not going to change anything. Top, we are going to change. So 4, we change it to 2 square, and the power remains. And we are going to multiply, where the 25 changed to 5 square already, and the power remains. Okay, so now we have changed all the base values to be similar, which is 2 and 5. Right, so now what we need to do is to simplify the indices here. So we have learned that if we want to multiply the indices which has the same base, their powers will be added together. If let's say we need to divide the indices which has the same base value, we need to minus their powers. Right? So let's start off with the values that has base 2. Okay, let's start off with this value. So for the 2 here, let me multiply with the power here. So here will become 2m and 2. Okay, and there's a value in the denominator here. Right, so if you just focus on the values that has base 2, it's like we are dividing this value. Okay, so since we are dividing, then we need to minus the power. So this 2m will become negative 2m minus 2m. Right, so this is for the values that has base 2. Okay, which is this one and this one. So now let's focus on the other base value, which is 5. Right, so we're going to put a multiply here, right? And we're going to put a 5 here, and for the 2, I'm going to multiply with the power, so it's 4m. And again, here you can see there is one value which has base 5 and it's in the denominator, which means we are going to divide with this value, which means we are going to minus the power. Right, so this 1 would be minus 1, and this 4m would be minus 4m. Right, so now you see for each of the base values here, we can simplify the power, right? 2m and minus 2m. If we add them up together, it will cancel off. 4m and negative 4m. If we add them up together, again, it will cancel off. So now we are just left with 2 to the power of 2 multiply 5 of negative 1. Sorry, 5 to the power of negative 1. So this one, we can just plug it into the calculator and we can find out the answer, which is 4 over 5. And for part 2, we need to solve this indices equation. Alright, so solving here means we need to find out the value of x. Alright, so to solve any kind of indices questions, we need to make sure the base values is the same, but now it's not. Right, one is 5 and the other one is 1, 2, 5. Right, so let us change the bases to become the same value. And again, we are going to change them to the smallest base value among here. Right, which is 5. So for the 1, 2, 5 here, let us change it to the 5 of power of something. Right, so if you don't know what value does it change to, it's okay. We can just put the values one by one into the calculator and find out its value. Alright, so 5 squared is 25, right? And if you put 5 cubed into the calculator, it is actually 125. Okay, so we have already found the value of the power already, which is 3. Right, so 5 cubed or 5 to the power of 3 is 125, and then we can change it to this value. Okay, so now for this part of the equation, I'm going to move it to the right side. And I'm going to multiply the 3 to the power here. So 3 will be 18, and 3 multiplied with negative 2x will be negative 6x. Okay, but why did I move this part to the other side? Hey, because we are finding out the value of x, right? The value of x here is at the power part, and the base value here is the same. So we can just ignore the base value and let's just focus on the powers. Alright, so for the negative 6x here, I'm going to move it to the left side. So here will be 8x, and then 8 I move it to the other side. So divide with 18, you will get the x value, which is 9 over 4. And for part B, we are solving a surd question here, right? Because you see the values here, there are the square roots inside of it. Okay, so here we have the area of a rectangular room. Alright, a rectangular room is 3 plus square root 3, and the width of it is 2 plus square root 3. So in part 1, we need to find out the length of the room, and we need to make sure it's in the surd format. So surd form means that we need to remain the square root if our answers have the square root. Let us not change it to decimals. Alright, do not change it to decimals. Alright, so we know that if we want to find the area of a rectangle, right, it is length times the width, right? So to find out one of the sides, which is the length, why not we use that formula, which is length times the width equals with the area. Okay, so now we have the value of the width and the area, so let us plug it inside this equation. Okay, so the width is 2 plus square root 3 and the area is 3 plus square root 3. And to find the length, I'm going to move this to the other side. Okay, but this cannot be our final answer because remember, in the denominator, it cannot have surds or square roots. Right, cannot have surds or square roots in the denominator. So how are we going to solve this? So the main technique to solve surds is to apply with its conjugate. So conjugate meaning the opposite version of the surd. Okay, because in the denominator we cannot have square root, so by applying its conjugate we can help to remove that square root or the surd. Alright, so since here is a positive surd, so means we are going to apply with its conjugate, which is the negative surd. Right? The value 2 here does not change. We only change the sign of the square root. Okay, so this would be its conjugate. the opposite version of the surd here, from positive to negative. Alright, so now numerator and the denominator we are going to cross multiply. Right, so let's start off with the numerator. So it would be this result. Alright, so for the last one, square root 3 multiply with negative square root 3, because they are multiplying itself, so the square root will disappear and it will remain its value, which is 3. Okay, and for the denominator, same thing as well, and this will be the result. Alright, and let us simplify the numerator and the denominator here. So the 6 here I minus with 3, so here will be 3. And for the things that have the square root 3 here, so minus 3 and plus 2 here, so means here it's minus 1, right? Minus 1 square root 3. Alright. And for the denominator here, so 4 minus with 3, so it's 1. And here, if we focus on the things which has square root 3, so there's 1 negative 2 and positive 2. So if we solve this thing, simplify this thing, it is actually 0, right? Minus 2 plus 2, 0. So we have removed the square root in the denominator. Okay, how did we do it? We applied the conjugate. So conjugate helps us to remove the square root in the denominator. Alright, so our result now is 3 minus square root 3 over 1, which is also 3 minus square root 3. And this would be our answer. So again, write it in the surd form, do not write it in decimals. Okay? And for part 2, it says me to find the difference of the length and the width of the room. So this one, very simple. It's just using the length and minus with the width of the room. Okay, so 3 minus square root 3 and minus with 2 plus square root 3. So here it would be 3 minus 2, right? If I move this negative inside of the bracket, so both of them would be negative already. So 3 minus 2 is 1. And this one is negative square root 3, negative square root 3. So we are adding up together. So this is negative 2 square root 3. And again, write it in the surd form. Do not write it in decimals. Okay, and let me add the unit here. Alright, so 1 minus 2 square root 3 cm. And for the last question in this paper, coming from trigonometric functions, and in part A, it says by using the trigonometric ratio, find out the value of this trigo value. Alright, so if you see trigonometric ratio, means that we cannot use the calculator to find out this trigo value. Alright, it needs to have some other ways to find out this value. Alright, so how are we going to find out this trigo value without using the calculator? Alright, so let me share you this technique, which is called 360 degree A method. Right? So for this method, it will be split by 2 parts. Right? Split by 2 parts. So it's 360 degrees and the A here. So let's focus on the first part first. Okay? So you can treat this 360 degrees as 4 things here. So 3, 6, 0, and degree. And each of these things here have their own criteria. So meaning we need to make sure the value here satisfies these 4 criteria before we go to the second part, which is A. Alright, so let's go through the criteria one by one. So the first criteria is 3. 3 here stands for the 3 main trigo functions, which is sine, tan, and cos. So if we see the trigo function here is not sine, cos, or tan, we need to change it. So now it's secant, right? Secant is not the 3 main trigo functions, so we need to find a way to change it. Alright, so we know that for secant, it is actually the inverse of cos, right? So why not we change this secant 135 to be 1 over cos 135 degrees. Okay, so now you can see the trigo function here is the three main trigo functions already. So we have satisfied the first criteria. Alright, so now let's go to the second criteria, which is 6. Okay, so this 6 is a bit tricky. You can think of it as a upside down p. At upside down p. Right? So meaning for the 6 here, you can turn it first and then you flip it. It will become a p, and p here stands for positive. Right? So meaning we need to make sure that our angle here, the 135 degrees here, it's a positive value. So if we see it's a positive value, then we have satisfied the second criteria also. Okay, and now let's go to the 0, the third criteria. So you can treat this 0 as one cycle, right? One turn or one cycle. So this one cycle, we know that it is 360 degrees, right? So this means we need to make sure that the angle here does not exceed 360 degrees. Okay, does not exceed 360 degrees. But here, if you see the value of the angle, we are within 360 degrees. So we have also satisfied the third criteria. Alright, and we can go to the last criteria, which is the degree here, which is quite straightforward, which means our angle must be in degrees, which we are seeing it now. Okay, so this angle has satisfied all 4 criteria, and now we can go to the big A here. So big A here stands for acute. So meaning we need to change the angle here to be an acute angle. And remember, acute angle is from 0 until 90 degrees. So how do we change 135 degrees to become an acute angle? We need the help of this method, which is the ASTC method. Okay, and we need to do 2 things. So the first thing is, according to our angle here, which quadrant does it belong to? So 135 degrees, which quadrant does it belong to? Okay, so it should be S, right? Because S is the angles from 90 to 180 degrees, right? So it's section S, or the second quadrant. Alright, so now we have selected our quadrant already, then we need to adjust our angle according to these conditions. Okay, so means if you want to change 135 to the acute angle, we need to minus with 180 degrees. So 180 degrees minus with 135, which would be 45. Right, so now you can see it is within 0 to 90 degrees already, which is an acute angle. So this is the first thing that we need to do, and let's not forget the second thing, which is quite important, right? So according to our quadrant here, we need to see whether this value is positive or negative. Right? So how do you do that? We need to look at the function here, the trigo function here. So in this quadrant is S. S stands for sine, and meaning sine is the only function that is positive, which means cos and tan is negative. So since this is cos and here it's negative, so means we need to add a negative here, right? Which is very important. Okay, so we need to do 2 things. First things first, select the correct quadrant, and secondly, to see whether it is a positive value or a negative value. Alright, so now we have found out it is 1 over negative cos 45 degrees, but we still haven't answered the question. We need to have the value of this thing. Okay, so to find out the value of this thing, let us use another method which is actually shared in the textbook. page 139 in the English and the Malay version of the textbook, which is called the hand method. Right? So how this method works is assume that this small finger here is the x-axis and the thumb here is the y-axis. And each of the fingers here have their own angles. Right? So since this small finger is at the x-axis, so it's 0 degrees, right? And then followed by 30 degrees, 45 degrees, 60 degrees, and this thumb is at the y-axis, so it's 90 degrees. Okay? And each of the finger here has its own two values. Right? So the first type of value will be starting from the x-axis. So it starts from the small finger here, and then followed by this finger, which is 1, and then 2, and then 3, and then 4. So this is the first type of values. Then the second type of values starts from the y-axis. So here would be 0, right? The thumb here is 0, followed by 1, 2, 3, 4. Right, so what does these two type of numbers mean? Okay, so for the green numbers here, which starts from the x-axis, it's for the sine function. For the values which starts from the y-axis, it's actually for the cos function. Alright, so how it works is, okay, let's say we use this value that we have now as example. So it's cos 45, right? So we look at the finger that has 45 degrees, which is this one. Okay, and since we are looking at cos, so cos would be the values from the y-axis, so it's 0, 1, 2. Okay, so we will be selecting the value 2 here, and what to do with the value 2 is we are going to put it into this value here. Okay, so means cos 45 degrees, it would be square root 2 over 2. Right? Because we put the 2 inside of the end here, so it's square root 2 over 2. Okay, so this would be our answer. And this is how we use the hand method, which I think is quite useful and it's easy to understand and memorize. Alright, so now we know the value of cos 45 already. So here would be something like this. 1 over minus square root 2 over 2. Okay, so let us simplify this thing a bit. So for the fraction here, let us move it up. Okay, so once we move it up, it would be 2 over square root 2, right? Okay, because the numerator and denominator, I switched their places, right? And there will be a negative here, so it's negative on the outside here. And again, our final answer, the denominator cannot have square root, so we need to remove it. So how are we going to remove it? Very simple, it's just multiplying with its own value. Okay, multiply with its own value. So if square roots multiply with its own, then the square root will disappear, right? So here would be 2 in the denominator. Then the numerator here would be 2 square root 2. And now you can see we can cross off the 2 here with the 2 on top here. So cross off here, then we can get the value of this thing, which is negative square root 2. So this is how we find out the exact value of this trigo value. Firstly, use the 360 degree A method. And to find the acute angle here, we use ASTC. And if we want to find the exact value, we use the hand method to find out the exact value. And for part B1, we need to prove this trigo equation. So to prove trigo equations, we can either from the left, we prove the things on the right side, or from the right side, we prove the things on the left side. Right? So to decide which side to choose, well, we can look at the side which is more complex, or meaning there are more things to manipulate here and there. Right? So if we compare these two sides, I would say left side is more complex, or there are more things to change here and there, because we can multiply these two functions and then we can change something here and there. But for this one, it's like 1 minus cos 2x. The only thing we can change is cos 2x, which is a bit hard, right? So let us start from the left and we prove the things on the right side. Okay, so if we see the values of the trigo function here, one of it is 2x and it is sine. Okay, so let us pull out all the trigo formulas that uses 2x or 2a. Okay, so here we have sine 2a or sine 2x, which is this result here, right? So let's change this sine 2x to be 2 sine x cos x. Okay, so now we have sine x and cos x inside. So for the tan here, how are we going to change it to sine x and cos x? Right, so this is very important because we have learned that tan is equal to sine over cos. Right, tan is equal sine over cos. So what we can do is for the tan here, change to sine x over cos x. Right, so now we can simplify this thing. So for the 2 cos x here, we can cross it off and we can multiply the 2 sine x functions here. So here would be 2 sine square x. Alright, so now from 2 sine square x, how do we change it to 1 minus cos 2x? Okay, so since we are changing this to become 1 minus cos 2x, so let us look at the formulas that uses cos 2x, which is formula 33. Okay, so let us look at the formulas that uses cos 2x. So now, we need to have 2 sine square x and we change it to this, right? So we need to see in the formulas in cos 2x here, does it have sine square x or not? Right? So if you look at these 3 formulas here, we have 2 of them have sine square x or sine square a. Right? So let's go through them one by one. Right? So let's say if we use this one, right? The first formula here means that there will be cos 2a or cos 2x and cos square x. But then if we use this one, there is cos square x here, but here it's not required, right? There's no cos square x here. Okay, so for this one, we need to reject it. Okay, because we don't want the cos square x, right? So if we go to the other formula here, alright, so here it's 2 sine square a or x, which we are having now, right? 2 sine square x. So if we use this formula, means that there would be 1 and the cos 2x here, right? Which we can see on the right side of the equation here, it's just 1 and cos 2x. Okay, so means we need to use the second formula here, right? Cos 2a equals to 1 minus 2 sine square a. Right, so now in the working that we have is 2 sine square x here. So why not we form an equation where one side of the equation here is only 2 sine square a. Okay, or x. I think we change it to x. It will be easier to understand. Alright, so if I move this 2 sine square x to the other side, cos 2x to the other side, so here would be 2 sine square x equals to 1 minus cos 2x. Okay, so let me rub off this a bit. Okay, so now you can see that 2 sine square x, which is the thing that we have now, if we use this formula, it would change to 1 minus cos 2x. Right? 1 minus cos 2x, which is the thing on the right side. For the second part, it says hence. Okay, so it says hence. Let us put a note here. So hence, solve the trigo equation where x is between 180 degrees to 360 degrees. Okay, so means later when we have the answers, we need to make sure the value of x is within 180 to 360 degrees, right? So let us put a note here as well. Alright, so let's solve this trigo equation, but how do we solve this? Okay, it's a bit complex, but if you look closely to the left side of the equation here, this is the thing that we have proven in part 1 just now, right? Tan x sine 2x is actually the thing that we have proven just now, and we have proven that it is actually 1 minus cos 2x. Okay, so since it says hence, means that we can use the result here, meaning we can change the tan x sine 2x to become 1 minus cos 2x. Alright, so now we can simplify this equation even further. So means the 2, I'm going to move it to the other side, so 1 over 2 divide with 2. And then I'm going to move this one to the other side, so here would be minus 1. And then I'm going to move this negative to the other side, right? So once we've done that, cos 2x will be equal to 7 over 8. Right, so now how are we going to solve this? So this one we need the help of the ASTC method. Okay, but this time we only need to do one thing. We need to select the quadrants here or the sections here where the cos function has a positive value, right? Because you see in this equation here, the cos value here is a positive value. Alright, so now from this ASTC graph, we need to see which are the quadrants where cos is positive. Okay, so A here, A stands for all. All here means for sine, tan, and cos, all of the functions are positive. Right? So this is one of the quadrants that we can select. Right? Because cos is positive. For the second quadrant, which is section S, so S is sine. Sine is the only trigo function which is positive, which means cos here is negative. Okay, so this is not the quadrant that we want. We want quadrants where cos is positive. So we can go to T. So T here is tan. Tan is the only function which is positive, which also means cos is negative. Okay, so this is not the quadrant that we want also. So let's go to the last quadrant here, which is C. C is cos, and cos is the only positive trigo function, right? So this would be another quadrant that we want. Okay, so it would be A and C, the first and the fourth quadrant. So now, once we have selected our quadrants, then we need to find the angles according to these conditions here. Okay, sorry, let me rub off this thing a bit. Okay, but how do we find the theta here? Alright, so for this theta, it's very simple. We just need to move this cos to the other side. Right, so means it is arc cos, right? So this is not called cos to the power of minus 1 or inverse of cos. It's called arc cos, ARC cos, and this is arc cos 7 over 8. Okay, so we just need to put this into the calculator and find out the value, which is 28.96 degrees. Okay, so if we want to find out the angles, it would be this value and this value. Okay, so the first angle is the theta, which is 28.96, and this value 360 degrees minus 28.96, which is 331.04 degrees. So using the ASTC method, it will always have two quadrants that we need to select. So means there will always be two answers. Okay, but this question is a bit special because it is 2x here. Right, so what is 2x? What does 2x mean? Okay, so let's understand what is x first. So x is just turning one round, right? From 0 until 360 degrees. So if we see for the first quadrant here, this angle only passed through one time, right? And it passed through the section C or the fourth quadrant here one time. But now it's 2x, so means the angle will turn another round. So now if you see the first quadrant here, it touches 2 times already. First time is here, second time is here. Same goes to the quadrant here also. 1 time, 2 times. So the angle here, now it touches 2 times for each of the quadrants here. So means in our answers here, instead of 2, now there would be 4 answers. Because this angle touches the first quadrant, which is A, and the fourth quadrant, which is C, 4 times. So we need to have 4 answers. So how do we find the other 2 answers? Actually, it's quite simple. Because this angle, it turns another round, right? Another round is another 360 degrees. So from our values here, we just add 360 degrees to get the next set of answers. So meaning 28.96 degrees plus 360 degrees, right? Which should be 388.96, and then we are going to add 360 degrees to this angle as well. So here will be 691.04 degrees. Okay, so 2x, it will touch the quadrants that we want 4 times, so there will be 4 answers. Right, so in summary, if we see x, there will be 2 answers. If there is 2x, there will be 4 answers. If it's 3x, that means there will be 6 answers. Right, so that is the standard number of answers that we have according to x, 2x, and 3x. Okay, so now we have our 4 answers already. So if we want to find the value of x, these 2 needs to be moved to the other side. So means all of the angles here, we are going to divide with 2. And this would be the result. Okay, so now our x value, we have 4 answers. But let us look back at the question here. They gave us this condition. X must be within 180 degrees to 360 degrees. So means for our 4 answers here, we need to reject this one and this one, right? Because both of them are lesser than 180 degrees. Okay, so we can write out a final conclusion here where our x, which is from 180 degrees to 360 degrees, our x value is 194.48 degrees, 345.52 degrees. And with that, we have completed the discussion of this paper. Alright, so thank you so much for watching this video. If you have any questions regarding the discussion of this paper, feel free to put your questions in the comment section below. I'll try my best to reply them as soon as possible. Alright, and for the next paper, I'm not really sure which paper I'll be doing next, but if you have any ideas, you can put your ideas in the comment section below. Alright, and also I would like to say this for every video that I've done this year. So for these few weeks which are very hectic for SPM, so I want to remind you all to take care of your health first, right? Because if you don't have good health, how are you going to get good marks? Okay, so for the health, I'm not talking about physical health, I'm talking about mental health as well. So if you really want to have a time to rest, feel free to give yourself that opportunity to rest. Okay, so please make sure your health is good for these few weeks. Alright, so again, thank you so much for watching this video, and I'll see y'all in the next one. Alright, bye bye.